So it's 9 o'clock UTC. I think it's time to start. A warm welcome to everyone. Good morning, good afternoon, and good evening. So as Peter wrote in the chat, I think we are at the moment from 15 different time zones. So I need to say hello in different ways. So today we are starting the next edition of the Standards in Action seminar before the beginning of the 52nd ISO TC211 plenary week, which, as it was mentioned already today, will be again in the virtual shape. This time, the title of the seminar is actually Doing Standardization Together, where we would like to show and highlight the importance of the joint approach towards the standardization across different domains, particularly in those domains where also location plays a significant or essential role. So in today's seminar, with all the interesting presentations, 8 of them we will have, you will see. We want to showcase good practices of such cooperation by internal liaisons, external liaisons, and also to present those that could be for potential future collaboration. So as said, so there will be different experts in this seminar as well. There will be a panel in which we will discuss importance of the standardization of the standardized location data for the health domain. Before we are starting, maybe just to repeat once again a bit of the, let's say, rules. So as it was announced already at the beginning, this session is being recorded, and all the recorded presentations will be available later on the ISO TC211 YouTube channel. So all the participants are kindly asked to remain with their microphone switched off and camera switched off while they are not speaking. If you have any questions, please use the ability of Zoom to raise hand or to put your comments or questions in the chat window. So maybe coming back to the program of today. So it will be, as mentioned, somehow in 2 parts. In first part, it will be dedicated mostly towards the cooperation of the ISO TC211, as mentioned before, to external and internal liaisons. So exceptionally, one presentation will be as well in the second part because of the logistic reasons. At about 10:30, 10:25, there will be panel where 2 chairs, Agneta Enberg of ISO TC211 and Michael Glickman from ISO TC215 will join. Also Chris Body from Australia and Jennifer George from Australia as well. And Serena Kotze as well. That will be discussion about location information and standardization for health sector. Then we'll continue in the second part, and it's planned that we'll with another 4 presentations, and we plan to finish at around 12:15, 12:20 UTC time. So that would be for the introduction, for the opening. So with that, I think it's time that we start. So I would ask the first presenter, Chris Body from Australia, to share his presentation with us. Please, Chris.
Thank you, and I'll hopefully you can see my slides.
Yes, Chris.
Thank you. All right. And Thank you, Simon, and thank you for the opportunity to start off with the standards in action. I think this is an important program that we have within ISO TC 211, and I think this topic is now very much important for us as a community to engage other groups that are now requiring spatial information. And Jennifer and I have been discussing bits and pieces of this for about 18 months around how does spatial and then health start to have this link into a better understanding of what's required in these domains. But I want to start off with some history around this and where we've come from and I think where we have to go to. So let's start with some of our key partners that have been really good for our community, and we've been really blessed by close collaborations with OGC, IHO, DigiWig and the UNGGIM. They have been a great avenues for us to not only have this relationship, but also to understand what is their requirements in their particular environments. And also we've been able to progress a number of our activities more broadly. And as we go into our existing liaisons, we have this internal and external environments that we have. And some have been really working well. And some of us basically have been, you know, as a group, we've been sort of engaging on an ad hoc basis and that sort of thing. So internally, I've just pulled out a couple of the top ones that I thought about originally. So TC 59, the BIM, and our work, we've started and we've had a couple of attempts at it. We've had a joint working groups and so forth about how do we get this modeling understanding of data information from the two communities, and then how do we progress more of the technical areas of integrating our models and so forth, which in some ways have been sort of successful, but we're getting there. The intelligence transportation system, we've also got a joint working group, and to get a better understanding around positioning and their geospatial graphic parts of their requirements in their domain, which is an important facet that we need to do. So sustainable cities and communities 268 is also one of those groups that have been significant in its development. It has a great relationship with the UN and around the Sustainable Development Goals. So therefore, it is an important facet, an important committee that we need to engage. And they are starting to look very seriously around geographic information for a smart city, which I think we've been doing in our space for 25 years, but it is something that the communities are now wanting this information. And the infrastructure that goes with that is an important facet. Externally, we've had some great relationships with Geodesy and the oil and gas producers, with Roger Lott and so forth, which have been fantastic, and the FIG, which they've submitted a number of programs for us to progress within our concept, or specifically around the land administration domain model. So we've had these established already, internally and externally, and we've been progressing reasonably well on that front. But I like to start to have these notions around active or passive engagement. And overall, I think we've been doing, if you look at our engagements and our list of liaisons and how we're doing it, if I was going to categorize it, it's been generally passive, with occasionally active environments that we've been actively involved in. And that's my views, but others on the call and others may think that differently, but that's from my observation, it's mainly about being passive. But on saying that, we've been actively involved in recent times around the data exchange and sharing for communities infrastructure based on geographic information. And this is, I think, the start of our broader engagements through other communities that requiring spatial information. And we've had also an example just recently around the space industry and their definitions around positioning and so forth, which we've had to basically put in quite a bit of effort to inform that community about where positioning or what where functions are around positioning. And then internally, externally around actively is around the food and agriculture and of the UN, which is assisting us in the land cover and land use, meta language and so forth. And of course, the land administration domain model that I've already mentioned. Passively, I think we've occasionally monitored around 207 around environmental management, and passively, I suppose, the World Meteorological Organizations. But again, this is I've just pulled out those two that I think there is probably opportunities for us to further engage that. So what's next? And this is just a list that brain dump from me around some of the topics and some of the areas that I think are going to challenge us as a community to really start to engage more actively as opposed passively. So we've had the transportation and ITS and so forth, and I think that's going to be more in the future than ever before. So that's one. Infrastructure, I think various infrastructure, and I've just had a look at one from the smart cities for tunnel utilities around their requirements for their system. They've got nothing to do, they have no reference around for them positioning or geospatial or geographic information at all in that standard at all. Urban planning, utilities, energy and health, and Jennifer's going to talk around health and how we've started to also utilises OGC's domain working group around health and so forth. And I think we need to look at that a bit more closely. And I'm sure Jennifer is going to present some of those further topics that we may start to think about. Building construction, we've already started, but I think this further work that we need to do. And so the domain modeling and so forth that means that the Canute is doing and leading and so forth is an important facet that we really get down to these areas. Tunneling underground is another one. Light poles, we've been discussing recently in Australia around how important light poles will be in the future around smart cities and what they're going to put into the light poles and so forth, the various sensors and so forth. So that's another area that we may need, we'll certainly need to do. Climate change and environmental is an important facet that not only the standards groups, but also industry and the financial sectors are starting to look at what's the impact on climate change in our environment and so forth. And we, reporting and those sorts of things. And geospatial information, or parts of that, will be of some benefit. Mining and agriculture and land cover and land use are pretty self-evident. Marine is another area that we've been assisting in, and IHO has done a fantastic job and references our number of our standards, and they've inputted into what their requirements and so forth, and international marine boundaries and so forth is also playing an important part in the future. Space is going to be, and from an Australian perspective, is when our country is new to space, but we've done a lot of work around the space components, about calibration and validation and so forth, and the sensors and so forth, which had been led by Doug quite a bit in Working Group 6. Sorry, so that's another areas that I think that's going to be a more aggressive, I suppose, of collaboration. Statistical, we've quickly, a couple of years ago, looked at that, but I think statistically through the UNGGIM work will probably also increase, and unmanned systems and drones and so forth. So that's quite more than half a dozen of topics that we've been dealing with, and potentially I think is going to increase it. So how do we as a community start to better manage this future programs through our liaisons internally and externally? So I've taken this from the OGC's environment and about some of the technical trends and so forth, and you can see how what we can expect in our environment of coming forth, and the list of in black text of about some of the things that we will need to look at in various formats and parts or throughout the standards and so forth. And we're doing some of that really well, but we've got some challenges in front of us. 3D and 4D environments are going to be a significant program in the future. So that just gives you a list, and telecommunications about 5G, and I understand there's going to be, there's now talk about 6G and so forth, and how do we do that? Various sensors and observations and so forth will also come, and then of course the spatial data on the web and producing that more efficiently, and the systems that we're going to future develop through APIs and so forth. So that's just one of those areas of thinking. Again, and I've taken again this out of the OGC's meeting on the future directions of the clusters that we're responding to, and we can start to look at how we're going to allocate and see if I think maybe looking at our liaisons, we may start to think about how do we allocate or put these liaisons into the tech trend clusters, instead of having them all spread out and down the page where you see them on our website. That's well and good, but how do we then link back to some of these activities that we're dealing with? And I think what we need to look at is maybe saying for connected to autonomous cars and so forth, we may want to say we'll put 204 into that category under that headings and so forth, and the urban digital twins and smart cities, we may want to put 268 and those sorts of things. That's just a suggestion that we could think about and so forth going forth, a better understanding and managing some of our relationships, because they are getting complicated. And we're seeing across the profile common themes that are coming across to the various domains. So in ITS, there is positioning. In space, there's positioning and so forth. But we should be saying to those groups, here is our solution, or here is our methods of doing this sort of thing, instead of having it all over the shop. So, so coming back to specifically to Jennifer's presentation, next is, so I've been collecting some newspaper clippings for the last 12 to 18 months about out of the Australian Financial Review on health and data and so forth, and also using, this one is about postcodes and so forth, and how did New South Wales government start to use postcodes because of privacy and those sorts of things, of aggregating a bit more around that information. So this is just a clip out of that about as we know, or as most of you should know, is Australia basically on the eastern part of Australia last 2019-20 was burnt to a crisp, basically, and we're starting to use fire maps and so forth. That is one, but after that we lost quite a few, 30 odd people. So that, and a lot of people were injured and so forth. So the health part, and how do we respond to after disasters and so forth, and what's information's required from a spatial point to support the health environment also. So that's just one. The private industry is coming on board and have got a huge knowledge base and so forth, and we're seeing companies basically providing additional information and services. So this is another example of doctor care everywhere, but they're using or could have potentially about spatial information to assist in their business model and so forth. And this is another group of doctors and so forth around patients and so forth, and using where their patients are located and so forth. So again, it's location based. And finally, the data share is for healthcare and so forth as a community. And Jennifer is in Melbourne and lockdown. Last week, those people in Melbourne could only go 5 kilometres, and I can imagine a lot of people saying, well, how far is 5 kilometres where I am? And how do I say that I'm on a map on their devices and so forth, how far they go? No, this week it's 10 kilometres, but again, it is around data and data sets and so forth around this. So that's just one example, just a paper clippings that I've been looking at from this point of view. So coming back to assistance from OGC and the futures directions topics from last year. So so the City of Things and the integrations of sensor data into the 3D models and so forth for a smart city, and then the digital twin and so forth, and how do we improve that? Traffic analysis for a digital twin and so forth, extracting insights into these satellite data to drive the urban environment and modeling and so forth. Health and the ethics around health, but also the ethics around geospatial and how are we going to deal with this? And that's going to be some of the challenges that we're going to have around that. The augmented reality and virtual realities and all sorts of things, and the simulation and modeling is going to, I think, going to be a significant component in going forth. And linked data and so forth. They were the major topics that OGC discussed. that I think the JAG and so forth, maybe we should start to have this discussion and communications around how are we going to do this. So finally, I've got a couple more. So these are the major themes. They're not extensive. These are just the ones that came to my thoughts fairly quickly. So smart cities and 3D and 4D, digital twins, smart grids, the climate and environment and marine. And then down that is the data integration. How do we start to inform, collaborate, understand other communities' requirements, and how do we then integrate this information? Because we may have to change ourselves to meeting the new technologies coming forth. APIs, I think, is going to be a significant driver. Sensors are going to be very important, and artificial intelligence and machine learning. There's also that, and the Internet of Things will also play a significant part. So what's next? And I think this is about the last one. Liaison, collaboration, and dialogue. I think that's where we need to do more collaboration and dialogue with various communities. We can't do everything. I understand, and that we need to pick and choose what's important for us in the near and medium terms and so forth. We need to start to strengthen our liaisons and links with other TCs and other communities and industry and academia. It's just important. Exploit the models and the systems we already have, and I think we're starting to do that. I think we need to further leverage the work on the UNGGIM work. And also we've started to look at reviewing the liaison network to see what we can achieve and not achieve. So on that note, I'd like to finish up and at least give our community and everyone else some thoughts about how we're going to start approaching this. And we've got plenty of other speakers on the call today to highlight further topics that we may need and certainly need to address more broadly within our community. So thank you, Simon. Much appreciated.
Thank you, Chris, very much for giving us this really extensive overview how ISO TC211 is supporting other domains and industries with location information from the standardization point of view. I don't see for the moment any hand raised or questions in the chat box. However, there will be time for have a discussion with you later on in the panel. So I will suggest then to continue. So we are happy here today to have Jennifer George. She's CEO in Strategic Commercialization Australia, and she will share her experience with us from the health area and how in this area how there is a need for linked location information with the health data, in particularly in this time, in the COVID pandemic time, where this is even more important. So please, Jennifer.
Thank you for the introduction. Can you hear me okay? No problem?
Yes.
Great, excellent. Okay, thank you, Chris, my friend Chris, for your overview. It was wonderful to hear all the different exciting things that you've been working on. And I wanted to also just note that I am also the chair of IT268 for this Australian Standards group. So although I'm here as CEO of Commercialization Australia, I'm also one of you guys. So I'm very, very pleased to hear all the exciting things that we're going to do together. So my aspiration is here to inspire you. Innovation is something that we all look at in the now, but I want you to see it over time. This is innovation is we're all, as Chris mentioned, we're all going to start looking at 4D, which is the element of time. I believe that the intersection of geospatial and medicine and medical is very much tied into time. So I hope this is more of a speech presentation than what Chris's was, but my aspiration here is to inspire you very much. So I hope we achieved that. So geospatial and health, it's about time. So here I am I'm speaking to you, as I said, as the CEO of Strategic Commercialization Australia. So no, it is about time, but I'm not wise enough to be able to sit here in front of you and say, I'm going to deliver the seminal project about speech about black holes and the beginnings of the universe, a la Stephen Hawking. Nor, you will be glad to hear, will it be a temper tantrum where I say it's about time, that where an impatient geospatial modeler is kind of saying nobody gets them, that they're just waiting for people to get their ideas. No, that's not the time I'm talking about, but certainly this is a presentation about time. For the last 15 years, I have been commercializing deep tech, and medtech is part of deep tech. Deep tech is really about science and engineering and how they work together. So I work deep in the weeds of all the innovation, often at the cutting or even bleeding edge. So some of the things I might be telling you about today, you might not have even seen before. So I've commercialized quite a few different medical technologies, and it's all part of my work. So health has many parts, and I can't talk about all of them, but I'd like to speak today about some of the different parts that we might look at from the geospatial perspective, not just health generally, but diagnosis, treatment, contamination, recovery, near-term prevention, long-term prevention, and chronic and long-term care. So you can see there's lots of different parts. Every time as an entrepreneur, I dig into different areas, I see both limitations and difficulties, but I also see opportunities. And each one of these areas in health provides an opportunity for us to do more with the health community, all with data and diagnostics, and turning and combining the geospatial data with these various areas. And I'm sure if each of you are looking at that list, you'd probably think, oh, well, actually, I know something that fits into that area, something that fits in long-term care, or a device that helps with recovery. So you already know some parts, but there's a lot of parts in all those different areas. So let's take a bigger deep dive into disease diagnosis, progression, and contagion, because, as Chris mentioned, that's the world I'm living in on a day-to-day in my lockdown kind of society that I have here. We've learned a lot about different diseases. So when we look at time, so I'm saying, really talking about time here. So if you think about it, when we look at accidents and things like that, we say, oh, time cures all wounds, it makes it all better. But when we're talking about pathogens, time actually is the ally of making that pathogen more voracious, more successful in the community. Because over time, simply put, diseases just get worse. It factors in as early diagnosis increases the effect of medication and reduces the life impact, but conversely, late or inaccurate diagnosis can be life-threatening and potentially life-ending. So if we can do something to help that transition from late discovery to early discovery through data, we can do an amazing amount of things. So we know about COVID. I mean, we're living COVID, but also there's a lot of other diseases, sepsis, pneumonia, HIV. They're all diseases that are related to bacteria. More recently in India, we found that there was major outbreaks of black fungus that previously wasn't life-threatening, but now because of the reduced immune systems, it is incredibly life-threatening for people who are already living with COVID disease. So we're kind of multiplying the effect because of the different kinds of compromised systems and diseases. Equally, time also worsens conditions like cancer, diabetes, all the other ones that we hear commonly are all impacted by time. So if we, with the geospatial world, could help with an early diagnosis, we could really make a substantial impact for the world here. So, but we know that COVID has improved our awareness. You know, everybody's an expert now. I mean, if you said PCR a few years ago, no one would know what it is. But I guarantee you that 50% of the population know that a PCR is just a machine for measuring the viral load of a COVID vaccine, of a COVID virus. So because of our use, we're actually going to become more aware. And so this is a change that's going to be happening, and that awareness should be matched with data collection. And so we must become smarter and more aware of how things work together. So we understand now that contamination works across environments. And indeed, we actually see that over time, and in certain situations, it's going to be worse. And those things can be all mapped through geospatial. Right? Digital technologies can help with this. And in the progression of various pathogens, if we can do something to change all of this with digital by bringing and combining geospatial and digital technologies and personal technologies, put them all together, we actually have an opportunity to change the health of the world, which is a really exciting thing that we could potentially do. So here I'm going to give you a bit of an insight into my world of innovation and things that you might not know are occurring. So here's a few of the innovations that I've looked at in the last month or so. So there's a new a new test for sepsis, and it has developed that we can test, because we use AI, this test can now test for sepsis in 1 hour instead of 3 days. Again, remember, time is the element that needs to be addressed here. There's a new device that allows you can do a digital measurement and use image processing to be able to see if you have sepsis from your home rather than going up to the hospital. Remembering that sepsis kills millions of people every year. It's one of the most life-altering diseases in the world today. There's a new helmet that's been developed to identify at an earlier point, maybe in a plane or an ambulance, if you have a clot stroke or a bleed stroke, and so you can get that treatment right away. And you only have 4 hours after you have a stroke to be able between the first stroke and total brain injury. So that means that you've got 4 hours, and if that 4 hours is spent traveling, whether it be on an autonomous vehicle or not, it doesn't really matter. It's the 4 hours you've got to get a diagnosis. So there's also a mobile phone. You can cough into your phone and figure out whether you have any kind of pneumonia or croup or any kind of, even COVID, and it's 85% accurate. A doctor is only 80% accurate. So the digital device is actually more accurate. So these are the kind of things that in the future that you might be looking at is, how do we standardize this? How do we bring in all of the new understandings that help to put all this together? There's also mobile ECG machines and epilepsy helmets that you can put on and play cards at home and have friends around while you're getting your ECG your epilepsy managed in real time. Diabetes and heart and pain, there's all kinds of ways of measuring and monitoring pain. In fact, you can use virtual reality to monitor pain in surgery. 60% of pain can be reduced simply by using the right kind of virtual reality. So these are some of the things that do we need a standard for that? Do we need to understand and make sure that people are using these things in the right way? Connecting all these technologies together, we've got Fitbits on our bodies, we've got telehealth, as was mentioned here. We, Chris talked about, we have a huge growth industry in telehealth, and what we'll be able to do is bring all these things together to be able to create new value. Okay? Add to this, you've got big data, AI, cloud computing, you've got the new ways of understanding, packaging, putting it all together. All of it goes together. It is not separate. It is not separate other parts of other things. We can't do a standard on cloud computing without thinking, well, what is it actually storing and how is it delivering value? So looking forward, we have new silicon chips. So the silicon chips that you have in your phone are the probably a midway iteration of where they are now. Silicon chips are going to be able to do 10 times more and give you at the same time 10 times cheaper and way more customization. So you can expect that every piece of edge computing technology that's available will have some kind of new smart chip in it very soon. And once an innovator gets hold of those things, you're going to see a lot of tech that comes out of that in the personal health space. So all of these things, you put these all together, they're not separate, they're all data. Everything works together. So we put them all into an environment with this data, with their data and environmental and geospatial data, we're going to have a huge impact. Think about the ability to customize and be able to say the environmental impact of these diseases on particular individuals. We can do testing in a lab and we could test, 10,000 lab samples and do predictive analytics on those samples in order to get to a result that would take us days or weeks. We can now do it in hours. So all of that must be considered when we're looking at standards. But in our rush to reduce time, let's not forget accuracy. I have to say, I just commercialized some COVID treatments in Europe, and I was like amazed, so US and Europe, I was amazed at these number of different technologies that were around that didn't actually work. And so it was kind of reassuring when I saw in the press that the FDA had actually apologized for approving so many new PCR machines that didn't work. They were all giving false positives and even false negatives. It was really that they didn't deliver any real value whatsoever. So they apologized for that. And similarly, the CDC revised down the point of care devices, those very quick devices that they said, well, okay, you can do a spit test or, a lateral flow test or whatever it was. They reduced their rating for those down from 80% effectiveness to 42% effectiveness. That means that less than 50% of the time they were getting it right. In a 50-50 situation of yes or no, we were getting it right. We were getting it more wrong than right with these new devices. So we have to understand that as we rush to save time and we want to get predictive and we want to make sure that we deliver a better result, that we actually need to get it right. Accuracy and fast, accurate and fast. That's our goal, not just fast. It's really, really important. So each data device, of course, creates its own data, and that data is collected within a standard. And the standard format helps all the systems to be built together with interoperability in mind. everything that is built today needs to be interoperable. We've got to look at the systems. Is it in Linux? Has it got the right telephone system? Is it all, is it proprietary? If it's proprietary and we can't add to it later on, and if it can't read any other information or be interlinked with other information, what good is it if we start to build the picture of somebody's personal health over time? It just won't work. So we need to collect all the data that's involved, right? And we need to be much more aware that that data is very important, and we've got to give it the big D, the big capital D of data, make sure that we're ensuring that we're solving a problem, that we're giving high quality data, that we've protected it, and that we've made it so that we're kind of working and setting standards that really make it valuable to everybody, right? And we can only do that when we look to the future instead of now. So whatever we have now is not where we need to be. Where we need to be is in the future, looking back. So if in 10 years' time, you look back and you say, well, this is, you know, we understood back then that the standards were required. We built our cities and we built our systems. Systems, buildings, architecture, infrastructure all last for 50 years. So now if we want to make changes by 2030 or 2050, we should be well and truly in progress right now. So we can't just assume that we will have a different kind of result if we haven't done anything different as we've gone along. We need to look forward and then come back and view our future and our past. So I know geospatial data and sensor design can't do everything. I get that. I understand that. We don't want to be all things to all men, or all people, I should say. But the reality is, if we work with our medical and health experts, you know, and try and work at ways where we can get more complete information, then we have the ability to predict the future. We have biological digital twins being developed. We have the ability to use bioinformatics to be able to see whether people are more responsive to disease or less responsive to disease. There's 30% of our population that cannot get a treatment whatsoever because they are not the group of people that medications are built for. We need to get more personal. We need to give them more customized understanding. So, but when it comes to disease, you know, really delivering impact by reducing the time is really in the wheelhouse of data analytics. And we need to embrace that, not just with fervor, but with a feeling of urgency and responsibility. We've got to do it well, and we've got to make sure that all of the elements come together with responsibility. So in the past, our standards have really just been the bottom, the do no harm part of standards, right? So we build a bridge so it doesn't fall down, or we, you know, say you've got to at least have made this area. We haven't necessarily talked about, well, the bridge needs to connect this community to another community, or and give them a quality of life. We only look at one element. We look at single elements. However, when we look at data analytics, we can put health and the environment together, and we can create customized treatments for so many people, customized new treatments for diseases, new understandings in health. And so we can be doing more for each individual, not just doing no harm. We can actually aspire, and we should be aspiring to doing better and helping to create more of a lifestyle success and health for everybody, not just those 70% that are in that normal and healthy range. So let's come back to our friend here, Stephen Hawking. While he may have given us more insights about time than anyone else in history, He also lived longer than anyone else in history with motor neuron disease. And but in order to do that, he utilized a lot of digital innovations, speech, movement, and things that were not even considered at that time. In 2009, we actually just come up with a way of actually using your real voice in the speaking situation for ALS, right? And remember, everyone remembers the American voice that the Englishman, Stephen Hawking, was given. Now you can use your own voice as of 2019. Also, there's telehealth services specifically related to ALS that so that they don't have to travel, that they can get a full health coverage. So all these kind of services are starting to become available. But you know what I said is try and keep your eyes open for innovation, try to see things that are on the periphery. Well, just yesterday, I saw that our own Melbourne University has developed an item called a stentrode. And what it is a small little item that is inserted into the brain of a person who has neuromotor disease. And with that, they are able to think action, so that they can think to move their emails, they can scroll, they can change the pages, they can write text, and it's done through the brain-computer interface. So seeing things, being aware as we are of tech, we are all going to be able to start to envisage and change the future in a very meaningful way. So keep your mind open and things moving towards the future. But unfortunately, there's no cure at the moment for ALS, so for motor neuron disease. But eventually, when we do find a cure, I'm sure the people that work with Stephen Hawking and people who saw him live his life for his 40 years with muscle degeneration, they will all stop and they'll say, well, it's about time. So there we are. Thank you very much. That's my presentation.
Thank you very much, Jennifer. It's really about time to giving to us this, let's say, enlightening and mind-opening presentation of yours, showing, as I understood as well, how location information on top of emerging technologies like artificial intelligence, digital twins can enhance and improve services in such a domain like a health sector. And I just checking if there are any comments at the moment. But as said, so you're also the part of the panel later on, so we will have a further discussion later on if there are no further questions at the moment. So once again, thank you, Jennifer, for that. And so for the moment, we are now going to the smart cities, I believe, with so Sang Ki will take us through the smart cities and show how to work together for smart city standards. So how ISO TC211 is doing its efforts with other committees, liaisons, internal, externals, to doing standards for smart cities. Please, Sang Ki.
Thank you, Simon. Can you see my slide now?
Yes, perfect.
Okay. Sorry. Hello, everybody. My name is Sang-ki Hong from Korea, and I'm a professor at Anyang University. And also, I'm a convener of Working Group 10 of ISO TC211. First of all, I'd like to thank Chris for his excellent overview of the situation, and also very inspiring talk from Jennifer. And after her really inspiring presentation, my slide would be quite boring. I'm afraid, because I'm really focusing on the some specific points that we can work together for better smart city standards. So this is just contents that I'll be giving, but I'll just skip that. Probably many of you are very familiar with this situation. The data, we are living in a world that the data silos are everywhere, and it seems that the most of the data seems to be working within specific domains or with related to few services. But when we try to integrate them and we use them together, there's a broken link between these silos, and there's no exchange of information and sharing of information. And the future that we all want to have is the right hand side picture, that in a smart city environment, everything is connected and every data is shared and that every service is available. So that is where we want to go. But how can we do that? So I looked at the some of the ISO TCs that has something to do with smart city. I should say that there are other standard development organizations such as OGC and the ITUT on the smart city subject as well, but I just limited my presentation to ISO TCs. Within the realm of ISO, there are 4 TCs at least partially related to smart cities. First one would be ISO TC 268, sustainable cities and communities, and the ISO IEC JTC1 Working Group 11 is smart cities, and there's also ISO IEC JTC1 SC41, which is Internet of Things and Digital Twin, which it's not quite smart city itself, but very closely related to smart city. And of course, we have ISO TC 211. And from natural environment to the services, we start modeling the physical world and collect data and build the data and process and visualize and use them. So I followed this process to sort of classify the works being done by these various cities, standard groups, and try to figure out how many standards are actually has something to do with geospatial information. So we are here and we are looking at 268 and JTC1 Working Group 11 and SC41 for digital twin. And if you look at the number of standards that actually have been published or under the development, there are several, 48 and 50, about 54 standards that may have some relevance. And I try to classify them into various stages from modeling to application level. And this is just the my own view and my own classification, and we will have plenty of chance to go over it and make sure that that is correct. But this is my first cut. For people who are not familiar with 268, TC 268 is a sustainable cities and communities. And as Chris actually mentioned about the SC1, Smart Community Infrastructures, and there are several working groups. Working group 4 is data exchange and sharing for smart city, smart community infrastructure. And they may have very big relevance to our work. And there are some relevant work in working group 2 city indicators as well. So I actually went through their standard work. Some of them are under development and some of them are published, and try to figure out what standard or work item we can work together. And I am not going to read all the things here. Just to show that the for example, second line, ISO 37156 is guidelines on data exchange and sharing for smart community infrastructures. And now we have been asked to make comment on the second line from the bottom, active work item TS 37172, which is the same thing based based on geo information. Chris also showed that in his slide as well. And this is my attempt to sort of bridging the both standards into this process that I mentioned. And the left-hand side is 268 standard, and right-hand side the 211 standard. And from modeling side, we can actually look at the what 268 is doing, and in terms of our framework and reference model perspective, and try to give some input to them. And from data build side, the ISO working document 37173 is information-based systems of smart buildings. We do have a joint working group, GIS BIM group. They may have something to do with their work as well. So this is a list of standard that we can actually look at and see if we can have something to work together. So in terms of processing side, as I mentioned, AWI TS 37172. From the data build side, I mentioned BIM2GIS conceptual level mapping standard 19166, as well as GIS BIM groups work. And modeling side, we should build data integration framework and governance for city data model. Based on TC211's framework and reference model, we should look at it. And I think that I remember that when we tried to contact them about the city model, they are not really aware of what's going on TC211 side, and that was a bit surprising, and that is one of the things that we are trying to solve here. I mentioned JTC1 Working Group 11, which is smart cities, and it is a group that was made to avoid duplicate development of standards and collaboration with each other between ISO and IEC. And they work on a lot of standard on smart cities as well. So I have table here, and if you look at some of the titles, upper level ontologies for smart city indicators, and a city data model here, foundation level concepts, city level concepts, service level concepts. The example of it, which is transportation, and model for data interoperability. So there are a whole bunch of things that we are really we have some relevance. So there are a couple of slides on this. ICT reference framework can be looked up from the framework perspective, and also a lot of metadata and metadata related things can also have something to do with their work as well. And working group 9's information management, and also moving features, linear referencing, and the GIS ITS joint working group work all have something to do with working group 11's work as well. So to sum up, we could work with JTC1 working group 11 on use of metadata and the related stuff, and also smart city conceptual model and how can actually that can be viewed from our reference model perspective. And also we need to identify the role of our standard in the smart city ICT reference framework. So there are a lot of things that we can actually work on. Internet of Things and digital twin. Digital twin is pretty hot these days, and actually they had an advisory group 11, and they actually, after the review summary from the report from the advisory group 11, they made the working group 6 on SC 41 for digital twin. And here is the list for some of the standards that have something to do with ISO 211 standard, and some use cases and concepts and terminology and vocabulary and a whole bunch of sensor related work. So I naturally think about OGCs, the sensor web, SWE environment, and things like that. Let's see, some smart grid related things as well, and underwater things. And here's a sensor network testing framework and things like that. So a couple of slides here, some working group 6 work, 7's work, working group 1 work, have some relationship, as well as working group 10, 4, and 7 standard are related to their work as well. So for digital twin, we actually we should make some use case scenarios, and maybe build a pilot system to demonstrate the best practice with the digital twin, and also harmonized services interface between geospatial API and IoT sensor network API, and maybe on modeling side down the bottom, we might want to look at some common conceptual framework and reference model between this IoT, digital twin, and GIS. So the middle part here, incoming interest or future interest, is where we actually are trying to go from here, and this came from the actually the revision of standard guide project for UNGGIM, and I looked at the OGC's tech trends and things like that, and came up with these titles: domain related and user interfaces and all other stuff. This is just my own classification, but if you look at the some of the highlighted words here, and these are the things that are very much in the trend, and I try to map a few of the columns that are have some relevance, but this needs to be looked at in more detail. But but as at least the modeling side, we gotta have something, we have to do something to resolve the reference framework. So how are we going to do this? First step is to understand what other people are doing. And basically, we don't know what they are doing, not really, and they don't know what we've been doing. So we need to see what's been going on the, some of these standard groups, and see if they examine the current state and maybe write a technical report and identify the common interest between different groups. And if we find some common interest, then we could create a joint workshop and try to develop common use cases and service scenarios, and maybe start a joint project and maybe test bed to see if it actually works. And finally, we could develop a joint working group working on joint standard. So this is the sort of suggested process for working together. And for a conclusion, I think that it's necessary to develop an integrated conceptual framework, because we don't know, we don't have the sort of integrated view of how all these things fit together. I mean, people work on domain specific areas and domain specific standards, but we really don't have any positioning of these standards and how they link together. So from another silo view of standards to sort of a better integrated view of standard, and through the some conceptual work and frameworks. And I believe the geospatial information standard would be the critical linking factor to make it possible. And that is my view, and I thank you for your attention.
Thank you.
Okay, Simon.
Thank you very much, Sankey, for driving us through this quite many complex ways of collaboration and contributing toward the smart cities from the location information perspective and standardization. I think there are already some questions there. Yes, indeed, from Thomas Kolbeck. Thomas, would you mind just articulating your question, please?
Yes, I can do that. Actually, my question is, I have two questions. First of all, I've seen now that in your slides, ISO TC 268 is now looking at city data modeling. My question is, do they consider also the OGC standard city GML, which is really addressing linking different application domains by a common shared 3D model of the environment? So that's the first question. And the second question was, that I've seen, you showed that the digital twin topic has just been added to JTC1 SC41. And so it's mostly now just under the umbrella of those people who are looking at IoT. And if you look at industry, many times also people think about digital twins being mostly addressed by sensors and by AI methods. And I personally, from my experience also, I'm deeply convinced that the digital and geospatial models of the environment are at least as important as the sensor parts. And so the question is there consensus about that, or is that not being seen? I think probably there is maybe consensus here in TC 211, but it should evolve, I would say.
Thank you, Dr. Kolbe. Can you hear me now?
Yes.
Okay. Okay. Thank you for your very excellent questions. First question regarding city data models. I cannot really say for TC268 because I'm not a member of 268,
Yeah.
but from the review that I got from their standard work, they are not really, as far as the city data model is concerned, they are not looking at OGC's work. So that is one of the reasons that we need to let them know that there is a very comprehensive data models for what they are trying to do. So so that would be answer to your first question. By the way, I didn't mention about ITUT SG20, and they are also doing a lot of work on smart cities and data models as well. So so probably I need to expand my presentation to include other standard organizations to cover the topic more comprehensively, but that is later work. And for your second question, I agree that the SC41 has now IoT and the digital twins, working group 6, but mostly these are IoT people, and then there are more things to digital twin than IoT, and then the environmental modeling and other sensors and AIs are all big part of digital twins, and they are aware of it, but I'm not sure whether they have any consensus on environmental modeling side of it and the sensor networking as well. So I had a chance a couple of days ago talking with the standard expert in digital twin, SC41 people in Korea, and they are really surprised that we have these things, and we've been working on this. So it is a first step to let them know that there are a whole bunch of standard they can actually use right away, and then start building up from that instead of trying to reinventing the wheels.
Yeah.
That would be my answer. I hope that would be sufficient.
Yeah, thank you very much. I think it's also always good to point out that there is not just the standards, but also the data already. So there are many cities worldwide which already have data in these kind of representations. Yeah,
that's correct. Yes.
Okay, thank you, Thomas, for your question. Thank you, Sankhi. I think Serena has a comment as well. Maybe Serena, would you like to elaborate on that?
Yeah, I think it also relates to the discussion until now. I think it's a very nice idea to have at the bottom a geospatial information model. And I mean, we can say we've got it already, but like Thomas pointed out, so there's already data out there. It's very difficult to break down the silos. So I think sometimes one also has to look for solutions for, converting data from one model to the other one, or mapping, the concepts from one model to the other one, because that will then make them interoperable. Maybe Sankhi has got some ideas about how such an integrated model could work.
Well, Serena, it's a good question. I'll think about it. It's a big question.
So breaking up the silos is also one discipline.
Yeah.
To master.
Yep.
Okay, so thank you very much, Sankhi. Thank you for all the questions by the participants. So let's jump from the smart cities into the water to the next presentation by Yonk Baek. Sorry for mispronunciation of your name. Yonk will share with us how IHO, so International Hydrographic Organization, has set up the standard based on the ISO 19 series. So please.
Okay, so good morning. Can you see my screen?
Yes, you can maybe just
okay.
The settings, yes. Or there are 3 dots, you can switch off the, yes, perfect.
Okay. Let me set things properly. Okay, good. So good morning, then afternoon, and evening where you are. So my name is Yong Baek, Technical Assistant Director working at International Hydrographic Organization. So thank you for again me to this Standard in Action seminar, and I'm very pleased to present the IHO standard activity. It's related to the ISO standard. So first of all, may or may not you know about the IHO. So firstly, I'd like to introduce briefly about what is the IHO. So IHO is the recognized international authority regarding hydrography and discipline of applied science, where the physical characteristics of the oceans are measured and presented. We are with the 94 members on 5 continents. The IHO set standards and coordination activity of National Hydrographic Office. So that means the old seas and oceans and navigable water are surveyed and charted. So this year is quite important to us. So the Secretariat of IHO is hosted by the Monaco government since its creation in 1921. So as I said, that this year marks the 100th century, the anniversary. The celebration will be held this month, 21st, the World Hydrographic Day. So if you are interested, so we are inviting to join the virtual seminar. So hydrography is focused on the physical features of oceans and coastal area, lakes and rivers, as well as the protection of their changes over time. So surveys record many features, including the coastal topography, and bathymetry depths, and oceanographic measurement, such as tides and currents. The data is used for nautical chart, but also geospatial applications and geographic information systems, GIS. So this information traditionally support the shipping, but now applies to all marine activities, economic development, security and defense, scientific research, and environment protection. So one of the IHO main tasks is to develop standards for marine species. The current digital standard used is S57, the transport standard for digital hydrographic data. A representative publication is, as you may know, the electronic navigational chart. But we have some limitations, technical limitations. So in order to overcome that limitation with the current S57, we announced a new standard. We call it the S100 in 2010. So S100 is a framework standard that is then intended for the development of digital products and services for hydrographic, maritime, and GIS communities. So it's comprised multiple parts that are based on the geospatial standard built by the ISO UTC 211. So S100 comprise multiple parts that are derived from the various ISO 19100 So the table on the screen, so it's with the individual part of S100 and their associated part numbers and ISO the 19100 conformance. So ISO, the base standards provide a large number of portions to develop for wishing to use them for practical application. So the concept of profile provides a method of adapting the base standard so that meet the specific implementation requirement. A profile is a set of or more base standards and where it's applicable and then identification of chosen clauses and classes, subsets, options, and parameters of those base standards that are necessary to accomplish a particular function. So ISO, for instance, ISO 19106 describes 2 levels of conformance for profiling the ISO 19103. So each part of S100 document, the level used in the conformance statement and for that part. So the S100 is a set of a profile of ISO TC211 standard for geographic information, and the relationship between the S100 standard core parts and the ISO base classes you can see on the screen. So I'm not going to detail the relationship on each part with the various ISO standards. So you can refer to the screen. In order to provide more the clear concept, what is S100? So I'd like to introduce some of the video clips. I'm not sure you can maybe, can you see? No?
Yes, we can see it.
Okay, now you can see it?
Yeah.
Okay, thank you. Thank you for confirmation. So this is the general introduction of the concept of S100. So the S100, so the meaning of the S100 to the maritime community is that lead to a global consistency of the products and equipment and software manufacturer implement as 100 levels. So, and also leveraging machine readable catalog for ease of updating the different product specification. An internationally recognized framework for the structure and delivery of products for the hydrographic and maritime community. So as you see on the screen is the S100 base product specification. So far, we are identified from the various the stakeholders and sister organization. So the green check product specification developed has been completed as a first edition. So the first edition means is a test version in order to be a release official version. And then the other product standard is still under development by the IHO or the IALA, the authority of the lighthouse, and then IOC, and Inland ENC Harmonization Working Group, and then WMO, and then IEC, and then NATO. So there are the various organizations and groups which are developing S100 based product specification. So IHO's digital publication are basically used for navigation safety, and S57 based electronic chart is currently used, but the paper maps in the past. So in accordance with the IMO, International Maritime Organization, SOLAS regulation, all international vessels must be equipped with the electronic chart display and information system. So the current S57 ENC chart is a two-dimensional information, but the S100 system will be four-dimensional, including time series such as the water level and current information. Based on the ISO 19100 series, the S100 improved the navigational safety for us and the route optimization and just-in-time, optimized loading, and automated navigation. The development of S100-based product specification is still underway, but the service is planned from 2025. This is one of the best practice from the member state. So in Norway, they are testing for the S1 or 2 product specification, which is the bathymetric data. So you can see on the screen that the giant ships could navigate in the very narrow and the shallow channel with the very precise the depth information, so they can measure when and where can navigate through this very shallow and narrow water. The other one example from the US, NOAA, is application to water level with S104 specification and also S111 surface current. So they are almost done to ready for the service from their website. So this is another best practice. The other best practice from the Korea, the hydrographic office, they are conducting a test on the various S100 base on ship on the board. So the International Hydrography Organization is developing a new digital standard based on the S100. So the S100 is based on the ISO 19103. So cooperation with the ISO TC211 is very significant for us. Thank you very much.
Thank you. Thank you very much, Jan, for navigating us through this way of cooperation between ISO TC211 and IHO. There are no comments and questions, but I think we have here also Doug O'Brien, who is also co-responsible for this cooperation. I think maybe Doug, would you like to add something?
Yes, certainly. Thank you very much, Young, for the presentation. It's very good to show people that the TC211 standards have real applications, and these real applications are nested in some of the requirements of UN agencies. For example, the UN Convention of Safety of Life at Sea, the SOLAS Convention, which is the background to the work that is being done with all of the electronic nautical charts. The thing that you will see here, though, is one of the real strong reasons why TC211 has to look at backward compatibility. Back in the early days when we were developing the S57 standard, and I was heavily involved in IHO at that time, I think this was in 1992, the then chief of the US Coast and Geodetic Survey, and Admiral Yeager, said that it would take 60 years for the US to chart its waters up to those standards as of 1990. And we've evolved a lot since then. So it's a matter of the data is important, is valid, and must be stable. And yet we must have a way of evolving and adding to it. So this is a very big challenge to ensure that the work of standards and systems in one organization can depend on that in another. And then I'll bring in the International Electrotechnical Committee, which has a committee on ships equipment, and there's certification of ships equipment. And part of that includes these ECDIS, electronic chart display information systems. And the IEC standards depend upon the IHO standards, which depend back on the ISO standards. So as you can see, there's a very long tail here, and things do not change quickly. One last point is it's not only the UN Convention on Safety of Life at Sea, there are other UN conventions. One of the standards, S121, is the standard for maritime limits and boundaries. And that addresses the UN Convention, the UN UNCLOS, if I can spell out, Convention of the Law of the Sea. And the Convention of the Law of the Sea has a section which describes how nations record their maritime limits. That's a nation's view of its own maritime limits according to the agreed convention, but this must be deposited with the UN. And so this was for many years done on paper and went into a filing cabinet and only ever came out if something ever went to court to try and resolve a dispute. Trying to bring it in digitally so that it can actually be made available has political implications because disputes may become more visible, but it has great advantages as well. And this advantage requires that the output not only be technically readable, but it must be also, and how one of the UN representatives said, it must be possible for two lawyers to read the document and have the same understanding. That's a very difficult challenge. So I thank Young for his input and trying to illustrate this requirement for stability of the TC211 standards.
Yes, thank you, Young, and thank you, Doug, for your comments as well on that. We are a bit behind the schedule, but I think it's always good to have this valuable and fruitful discussion we are having also today beyond the presentation. So we are now approaching to the next part, which is the panel discussion. So I will ask all the panelists to switch on the cameras. So while panelists are switching on the cameras, maybe just a few of the background. So as you can observe, ISO TC211 recognizes really the great potential in the health sector, benefiting from using standardized location data. So far as we've seen, particularly in determining when interventions are needed, where the increased accessibility of services is needed, model the spread of diseases, find most effective delivery models, and so on. Moreover, several countries worldwide now report also using the ISO TC211 addressing standard 19160 to monitor and block the contagion chain of the COVID-19 disease. So these are some, let's say, input before the start. We are starting the panel with our panelists today. So we have two chairs of the technical committees, Agneta Engberg, TC211, and Michael Glickman, TC215. And then we have two of our speakers, Chris Boddy and Jennifer George, both from Australia, and Serena Kotze from member body of South Africa. Maybe starting this panel, let's say the beginning with the title of this session, this seminar today, which is actually doing standardization together. Maybe to start with Chair of TC211, maybe to share with us a bit of thoughts what these doing standardization together represents to ISO TC211.
Thank you. Thank you so much. I hope you can hear me.
Yes.
Okay. Okay. Thank you. My name is Agneta Engberg, the chair of TC211. And first of all, thank you all for these very interesting presentations we've heard so far. I also would like to say that I'm very pleased to have my colleague, the chair of TC215 here today, joining us, and you will hear from Michael just after me. So what can you say that's smart in 2 minutes and suitable for this occasion? Actually, I would like to maybe zoom out a little bit and looking at the theme is geospatial and other domains, but in particular health here. So before I say what I think needs to be done or what we should do, I would like to say that regardless the accelerating needs that we see both in location data, but also in various domains like health, for instance. So regardless that we see the speed of the need here, the urgency, I think it's very important to see and recognize the challenges. And I see clearly there's a dual challenge here, I think, both in geospatial and both in standardization. And I would like to share with you just a few examples what I mean. Looking at the geospatial, I think the interdisciplinary nature is both its strength but also its challenge. I am right now involved in a study for the Swedish government looking at skill supply for the geospatial sector, because at least in Sweden, there's a decreasing amount of geospatial students. And I saw something in the chat about resources. So one preliminary result is that one problem is the embedded in the interdisciplinary nature of geospatial. And young people, they don't know what do I become when I grow up if I study geospatial. And even though they have all the apps and things, you know, already when they have diapers, basically. So it is one of the problems, but there's obviously other things, funding and other things. But the bottom line here, that the interdisciplinary nature, I think it starts in the schools already, making students wanting to become a geospatial scientist or whatever. So looking at just shortly then, looking at the other challenge, I think that we have common with very many domains, it's standardization. And maybe you did or maybe you didn't read in the newspaper this week about the work from King's College London on the database of the world's biolabs. I think it was a report for the WHO. Anyway, basically reading through because there was a nice interactive map. And at the end of the article in the Swedish newspaper, it said, well, there is a standard, ISO 35001, published 2019, biorisk management for laboratories. Not one of the world's 60 high-risk labs uses it. So Obviously, there's a joint issue here that we join with very many other standardization communities. So the bottom line I would like to have here is, however the urgency and the needs to reach out, we need to involve and guide those who have the benefit. And I think this has been sort of a red line already. Chris started by saying active relations, active liaisons, and someone else said we cannot do everything. So get involved with those who are benefiting from it from all levels. That this could be in any level. We cannot do standard in isolation. So that's my bottom line. Very generic. Thank you. I'll give the word back to you, Simon.
Thank you very much, Agneta. Maybe continue with the same question to Michael Glickman from ISO TC 215. Michael, are you with us?
I am. Can you
yes,
hear me?
perfect. Yes, of course.
Very good. Very good.
Please, Michael.
Thank you, and good day to everybody.
Here. Yeah.
And I want to thank you for inviting me. It's an absolute pleasure to be here representing ISO TC 215. And in the title, you talk about together. Well, we are all about together in TC 215. Our technical committee is about health informatics. And to describe that in simple terms, the way I like to think of informatics, it's about computability and interoperability. We hear that word a lot. So the notion that the data that's collected in one place can be used in another place is all about interoperability and computability. And we go a step further with interoperability because, and we refer to it as semantic interoperability. So just the fact that a mail, that an envelope arrives in the mail, if I open it up and it's not in a language that I understand, that's not very good interoperability or computability. So, that's very important to us. And we find in this notion of working together, and I'll give a couple of examples in a moment, there's, as my father used to say, there's not enough time in life to make all the mistakes yourself. But, we want to be a chapter in other books, other, horizontal domains, if you will, rather than write our own book, because healthcare has some special needs. There's no doubt about it, but it's not completely unique. So we have special needs in the area of privacy and reliability and security and efficacy. Safety is another area, especially patient safety. Persistence, data, and provenance, that I know where the data came from. I know that actually is a doctor that entered that information. In fact, we have an electronic health record in healthcare. We have an electronic health record and we have a personal health record. And they are fundamentally different because the data, while they're both data collected from a clinical professional, like a physician, is different than data collected from a patient. So it's hard enough when you have professionals sharing data and you want to create computability and interoperability. But when you have that kind of difference, it makes it even more difficult. And we differentiate between those two. So, and just another example of the semantic interoperability issue. If the use case I always like to give, because it's so relevant right now, is reporting adverse events, adverse drug events, or adverse vaccine events, or any kind of adverse event. In the world today, before we did some work that called, when you reported adverse events, how do you aggregate that data if everybody's calling a drug by a different name around the world? So it took us over 5 years, but we created a standard called IDMP, the Identification of Medicinal Products. And it is used so that around the world, we're all calling the same drug by the same name. And therefore we can report adverse events. I mean, we talk about big data, but what good is big data if we're all using different terms? And you'll hear words like terminology and vocabulary and tautologies. I mean, they're all different ways of representing information or representing data so it can be aggregated into information. And we have to make sure that all works going in and going out. Um, since we're talking about together, I'll mention JTC1. They've come up a number of times, but we use this very similar concept in dealing with JTC1, that they're a horizontal group. And we were one of the first groups to work with JTC1, where we're focused on the vertical of healthcare. So as two examples, we are working with them in the notion of data compression. So they in healthcare, there's DICOM images, diagnostic quality images. So JTC1 created compression that was lossy and lossless, so that these data sets can be transmitted, to around the world, if you will. And then there's also that same issue where we now went back to JTC1, the subcommittee, and we're talking about data compression for the gigantic genomic data sets. So that's an area where we've worked with JTC1, and we have a number of different liaison relationships. Some of them are, and we call them enhanced, liaisons. Sometimes we're just reporting back and forth to each other. Often we have a number, over a half a dozen joint working groups where we work together on a particular item, with one TC as lead, if you will. But the work is actually done by a joint working group with representatives from, all these liaison efforts. So when it comes out the other end, we always find it's easier to standardize up front than it is to harmonize it at the end. And then, finally, to wrap this back around to the subject of geospatial, in healthcare, there's no doubt we're using geospatial a lot for equipment, and we're starting to use it for staff, both ancillary staff and the care teams. Eventually, we would probably want to look at it for patients. But again, the big issue that we have in healthcare is efficacy, privacy, security, safety. So, we bring those requirements on top of the other horizontal efforts. And, I'll close with a final example. We're working with JTC1, the Internet of Things guy, folk. But we think about our contribution as the Internet of Medical Things. So what is special about medicine? We clearly don't want to start all over again. We want to leverage, and the same is true with geospatial. We want to leverage the work that's being done in all the areas, all the discussions we've already heard and will be hearing. But when we do that, we want to be able to do it, effectively.
Thank you, Michael, for sharing the perspective of the TC215 with us, and also to emphasize maybe the general needs and the issues that you're experiencing. So maybe to Chris, in your introductory presentation, you present already how ICT, ISO TC211 is doing in practice in collaborating in different liaisons. And Sankey also mentioned what are the possible ways to start some things doing together and collaboration. So hearing all that, so what from your point of view could be the starting points for the health sector?
Thanks, Alan. Look, I think that we've already started by having this presentation and so forth. I think that and what Michael suggested around semantics and vocabularies and data, and how do we get, I suppose, location-based information assisting not only health but other sectors, is to understand where we can meet with the various groups on that technology stack and so forth. So I think if there is a willingness from communities to say, we would like to have location information associated with our industry, then we need to further discuss a joint one about, okay, then where do we meet in our information stack and our terminologies and so forth, that we can seamlessly move across our information from one side of the domains to another. And I think Serena or someone has indicated that we need to have a transfer and so forth if required. So the conversation needs to start, and it needs to be an active one. This is where I'm suggesting is that we, in certain domains, we need to move from being just passive to be more active. But as Agneta has also indicated, is who's going to do that? Who's going to do that now and into 5, 6, 10 years time also? So that's another challenge that all of us are really challenged by, the resources that we're going to have now in the future. Thanks.
Thank you, Chris. To make the cooperation active, maybe it's time to turn to Jennifer to ask her further question, maybe. So in your presentation, you mentioned that there is a need to collaborate, that location standardization should have an important part in the future health activities. On the other side, one of your statements are also, in our rush to reduce time, let's not forget about accuracy. So having all that in mind, what ways of cooperation do you see, and where do you see the most urgent needs for cooperation from the perspective of the health sector?
It's it's a really interesting question, and something that everybody wants to talk about is collaboration, not just in the health sector, but in every sector. I worked in 5G and transport, and everybody's saying, let's cooperate. Let's, let's try and, did you want to stop my video or? There you go. Okay, sorry. Yeah, so people are asking, let's coordinate, let's cooperate. It's not easy to cooperate. And that's what, I'm hearing all these different, people have different versions of what is the actual truth, what's important, what is the standard, how do we interpret that? It requires a really concerted effort to start to think outside the box and put things in the other person's point of view. And we in the standards group have to understand that and be aware that if we have a deaf ears to those kind of things, we're going to be looking like we're completely clueless. So it's important that we understand that all of the different technologies help us to understand specific models. For example, Robert, you mentioned from about the virtual models that were being made, the in silico models were being made, and that perhaps that was a way of creating a digital twin or a rendering, or has places where we can see technologies put in with big data, and we can see it with geospatial data. Yes, absolutely, that is a place where it will happen, but we won't be driving it. Our problem is going to be, we will be left behind waiting for the bus if we don't kind of go ahead and embrace the different technologies. Today, I saw a 3D model of the inside of my head, right, in real time, which the surgeon could pull apart and be able to identify what is the surgery is going to be inside my head. We need to be so much more proactive about understanding how these 3D models, the digital twin or bio twin for a person, all of those things are fitting into the data of our everyday lives and making new diagnostics and new understandings of personal individual health, and creating. So we've standardized it on one side, but on the other side, we've individualized it. So there's going to be this constant push-pull of the two different kinds of approaches together. So embracing and seeing and understanding change, but also having that mindset of, well, standards is about, first of all, it's about caution and understanding, but it's about scalability. If I have a standard, I can then, from a commercialization point of view, I can say, as long as you build it like this, it's going to be suitable for lots of people and we can make a commercial business out of it. So understanding how people use the standards and how their constant use is going to be changing. And so the only thing that will be constant is that they will be looking to use them, but everything that they'll be using them on is changing. So we've always got to start to say, well, how can these standards be adaptable? How can they change with different people's experiences and in different geographies? And we pull all that data together and bunch it up as needed, rather than this is how you have to have it. They have to be able to have like a delicatessen of different kinds of data that describes them and that helps them to be the individual that they are, but also then have a standard that draws it up together and says, this is how we compare one with the other. I hope that helps.
Okay, thank you very much, Jennifer, to share your thoughts with us. So maybe turn to Serena. How, let's say, not to break up the silos is not to waste a lot of time while waiting on the bus, as Jennifer said. So how location sector can respond on all these needs, and what actually ISO TC 11 has already to offer?
Thank you, Simon. Yeah, so I think there's already a lot out there that people are using without knowing it. And this is the thing: if a standard is invisible, then it is successful. Then it's being implemented. I mean, if you just start by ISO 6709 about the latitude and longitude that everybody is using, I mean, then there's the feature model, you know, points, lines, polygons. That if you put spatial data into PostGIS or Oracle Spatial or any of these, then you are using that standard. So I think we shouldn't forget maybe that fundamental geospatial info or that integrated model is already there and it's already in use. And if we don't see it, it may already be there. And if I go through the list of things, especially now with the pandemic and the things that one can do in terms of, you know, preparedness or response and so on, there are many standards in ISO TC 211 that are relevant. I mean, if you look at predicting how the disease will spread, so you have to analyze places that people frequent. And there's, for example, the ISO standard on transfer nodes for public transportation. So knowing where those transfer nodes are, knowing what their shape are, what the layout is, how they connect to other transportation modes, that already can help you to share data, and then that can be used if you have that data to analyze it. If you look at how you want to prevent the spreading of the disease, you need to know where people are, and the whole that initiative of integrating geospatial with statistics is relevant there, because then you have the demographic data and you have the population data. If you look at mitigating the spread of the disease and contact tracing, then that's where the ISO addressing standard comes in. If people, so on the one hand, they have to enter their address in the correct format, but on the second hand, also, once they've entered it, you have to cross-check that that address actually exists. I saw a story where people, and I think even, I was expecting this about South Africa, but it was actually an example from Germany where more than 50% of the people on a list could not be contact traced because they just put in random addresses. So, and the addressing standard helps you not only to enter the address in the correct way, it does everything in the behind the scenes to have that data available. Then there are things like strengthening the health system for preparedness. So you have to know where your hospitals are, you have to know what the catchment areas are. So once again, it's about having that integration with statistical data, but it's also going back to the basics of, you know, looking at routing, looking at accessibility. So how long does it take me to get to that hospital? Then there's that integrated system of referrals. If I end up at the hospital closest to me, they may not have the facilities that I need, so they have to refer me further. And for all of this, people are again going to make use of geospatial information. And I think a lot of that is already happening, and it's already based on geospatial information, and it's already based on TC 211 data. So Agneta said that about geospatial being the integrator and the interdisciplinary thing. And I fully agree, that's a strength and the weakness. And we see the same thing, is that students don't know what they're going to get when they come here. So that's our powerful thing, but that's also the reason why we have to involve all the other disciplines who are using the geospatial data. And then lastly, if you want to monitor and communicate how the disease is spreading, then you've got all these dashboards, you've got those online maps, that information gets shared. There are things like the web feature service, the web map service. There's now the open API that will make these things possible. So I think, to get back to your question, Simon, I think in terms of what ISO TC 211 has got on offer, there's already a lot that we've done, and there's also already a lot that's in use. We just don't necessarily see it, but I think there's also obviously opportunity to expand on that. Thanks.
Perfect. So raising awareness about what has been used is also very crucial here, I think. Okay, so maybe panelists, do you have any reflections on what have been heard from your colleagues at the moment? Would anyone to reflect on something? Maybe Michael, Agneta?
Oh, I'm sorry. Surely. I enjoyed this conversation, hearing from my colleagues. To me, this is about, I mentioned semantic interoperability. I'm glad that concept stuck. The example I like to give, if you're looking at apples and oranges, and you don't know it, in healthcare in particular, that's very dangerous. But if you're looking at apples and oranges and you know it, you can make inferences about fruit. Just don't tell me about different kinds of apples. So, the issue here is that, what are the data? How are they being used? How are they being used in a consistent, safe, and reliable way? And if we don't recognize that we have to have this semantic operability, as I mentioned earlier, just getting a package at the door and not being able to read what's inside the envelope is not of a whole lot of value. And one of in the geospatial world, I think if we focus on a use case, the problem is boiling the ocean, everybody says. Use cases give us a focus, something to do our engineering around. You talk about piping, is it a building or is it a house? So an area that I think is going to could be useful as a super use case is the area of patient care devices. So these devices are located all over the place. It has security implications. You want to know where it is. You might be doing medication fulfillment, and administration, that the drug was actually administered and the person took the drug. And where were they when they took the drug? Even when you're in a hospital, they need to, they want to know who you are, where you are, that you're in this particular bed, et cetera, et cetera. So I think, an area where we can work together is in this area of patient care devices. And we've already done that, because there's a number of ISO TCs that are focused on the medical device, the regulatory device that the FDA and the EMA and all these regulatory agency, regulate. But that focus on the devices is an important one.
Okay, so knowing good about the apples and the oranges is maybe a good way to do a good fruit salad. Agneta, what maybe your last comments?
Yeah, can't see myself in the video, but it's somewhere there. I wanted to say that all the panel discussions and also the presentation so far, it's really given me more than I expected when it comes to concrete ideas and tangible ideas. And I think that we certainly need to follow up on this in somehow. And I'm a person, I need to look at this and discuss it again, and then think about it, discuss with colleagues, and of course come back. So a follow-up, and there's really come up great things here, great insights. Thanks.
Thank you. Thank you, Aneta. With this, I would suggest to finish this panel discussion. So thank you to all the panelists for your views, for your comments. We are already quite.
Thanks for inviting us.
It's a pleasure. We are already a bit behind of the schedule. However, we've been now for 2 hours together. So even though it was not planned, I would suggest that everybody will take a 5 minutes break so that we can go for a glass of water, a cup of coffee, and then continue at 11:15 UTC, so in 6 minutes. So I think it's good that we have this 5 minutes opportunity to get the essential things, and then to recess in 11:15. So see you in 5 minutes.
Okay.
So I hope we are all coming back slowly. Get ourselves a cup of coffee and a glass of water. So we'll continue. So we're sorry we're a bit late, but I think it's worth because of the very interesting discussion we've had so far. So we continue the second half of the presentations, starting with Peter Paslow from UK, that will share with us that standards are not always right. So please, Peter.
So hello, yes, my name is Peter Paslow. I am from the UK, but I'm sharing in a sense more on the basis of being the convener of TC211's program management group. So, right, in theory, you can see my slide, but I can't tell us whether you can or not, of course.
No slide yet.
Nothing seen yet.
I have to find Zoom again somewhere on this computer. Second try.
Now it's better.
So, yes, we've heard a number of interesting presentations. I was going to say this morning, that's the case for me, but this afternoon for some of you, several of which have presented the challenge in a way of getting more of us or more of our time involved in order to engage better with communities such as health or smart cities. This next few minutes is going to be about things we've put together to help people get engaged in standards development, starting from if you're a user of a standard and you find something wrong with it, what can you do? So by that. So what we've always had, or it's longer than I've been involved, is what we've called a standards tracker, but recognizing that GitHub is a useful technology that a lot of particularly software developers, but also others use for collaborative working. We've moved our standards tracker across to GitHub. So you'll see something like this. We'll look at it later on. So there's the top part here is standard GitHub stuff, and then a brief introduction if you go to that URL there. I'd like to thank particularly Greg Bowler of OGC, who did a lot of the work to make this happen, Knut Jetland, more involved with ISO TC211, who really did a lot to design how this looks in GitHub, how to make use of it. So Greg particularly migrated everything across. Now, what this means is anybody can look at the issues, the problems that are reported against our standards. It does mean you need an account in the same way as you did on the previous standards tracker, but if you have a GitHub account, you can use that. If you aren't allowed to have a GitHub account, then you can just email your issue to us and we'll load it. So you raise an issue and you tag it. We only found out last week that to tag an issue, you need to have right access on the repository, which you can request. But if you don't tag it, we'll tag it for you if you like. So if you find an issue that relates to two standards, you can tag it with both of them, or you can tag it as a new requirement, something you think we should standardize and haven't yet. And you can tag it with other things, particularly if you're asking for a change, it helps us to know what kind of change you think it is. So what happens then? Well, the program maintenance group, particularly the convener of it, currently myself, will look at it and assign it to the relevant group within TC211. The working groups get on then with doing the work. Now note, many of the working groups will also use GitHub once they have a project up and running, but that's often a private GitHub presence. It's separate from this one. There are, at the moment, 285 issues. More than half of them belong to just two standards. So what this brings up is that some people create an individual issue for everything. A spelling mistake is an issue, and that's perfectly reasonable. We can cope like that. Other people create an issue and attach a PhD thesis to it saying the work they did using the standard and the problems they found. And we then can deal with that too, because we're just open to, we want to find out what's wrong so that we stand a chance of fixing it. So in GitHub, this is a snapshot taken a couple of weeks ago. The working groups each have a project, and you'll see on the left there the 5 issues that are assigned to working group 4, and they'll use that as part of their agenda in their working group meeting to say, right, is it time to fix this? You know, are there enough of these relating to the same standard 19116, you know, that it's worth initiating a revision? And then anything that's got a current project will sit in here, and so on. So quick tour. And now, can I make this share something different? I suspect you're not seeing what I'm looking at anymore. Apologies. Didn't think that bit through well enough. So what I'll show in here briefly, we've had a new issue raised yesterday, suggesting that in 19103 we need to improve what it says about code lists, because the good practice in the world has changed. So the person who posted it, thank you Heidi, put in a description of what she sees as the issue. I've put in my thoughts, and as yet it's not assigned, but if you have the right permission, we can say, right, this relates to 19103, so we'll tag it with 19103 and so on. So I won't show you a lot of work in there. If GitHub is familiar because you're a developer of any sort, then that will all be familiar to you. And I realize I've done all that without clicking the share. Apologies. Now I should flick back to the presentation. That was a mess. I should have just stuck with the presentation, I think. Sorry. But if you're unfamiliar with GitHub, it is really just a website. And you know, like many websites, you click on links, you find your way around. And if you're finding it difficult to use, then do get in touch via the Secretariat. We have, for example, found out only last week that you do need write access to the repository to tag things, but any GitHub user can create an issue. So now you've reported the problem, perhaps you want to help fix it. Now, obviously, in GitHub, you can provide, you know, what you think the solution should be. You can comment on the issues and say, oh, I think I can see how to fix that. And that will be very valid once the project does get up and running. But what we've also done is to put together a good practice guide, which is designed to help people who want to get more involved. So if you are a member of a national committee or a national chair particularly, this hopefully is something you can point to your committee members at and say, look, get involved in TC211. It's not as hard as you might think. Here's how they work. Or if you're not involved at all yet, this is on our website there. And the idea is it's an introduction to how we work, who we are, who does what, how they do it. So thanks to Mats for putting all this information together on our website. So it includes these sorts of things. What are the different roles? Like any organization, we've got our language and our quirks. All this description fits into the ISO directives, you know, the rules that tell us how we have to work. But sometimes there are little adjustments and changes or just specific things that we do in TC211. So if you're involved in a standards project, it goes through a lot of stages. If you're in the project team, you'll see most of the work up here is in the first half. So although the project might say it's going to run for 2 years or 3 years, expect most of that work to be in the first year. There's a good principle, the more work that's done earlier, the easier the later stages are. Now, this can be reduced. For example, if OGC has done all the preparatory work already, and we've got one of these at the moment, we can come in at the committee draft with just 30-day vote on whether TC211 thinks that OGC standard is appropriate to go forward as an ISO standard, and then it goes out for a public vote. And then after that, it depends if we get any comments from the public on, for example, OGC API features part 2, as is in this 30-day vote at the moment. So the good practice guide has got a lot of links out to other things. It's got a lot of, this is the area sections on how to actually write the document or change the document, about text, about diagrams, about UML modeling. And it pulls together things that we as a committee have created over the last few years to help ourselves and others to work consistently. Now, that of course brings up that even what's good practice will continually evolve and change. So sometimes the committee as a whole, as we said recently, we've decided these are the URI patterns we will use. So we put that into the good practice guide. But it could be that you just uncover something that's not well written, you don't understand it, or there's something else you'd like to be clarified. So there's an email address on there. You can suggest the changes you want to make to our good practice. And what happens then is PMG considers whether we think the suggestion you're making is appropriate. And if we agree it is appropriate, then Mats can change the page. So the whole aim of this is to be clear, useful guide to help people in developing standards. And that was all from me.
Thank you. Thank you, Peter, for sharing this with the community. So how people can engage with the standards, with production standards and comments on standards. And I suggest that we are continue. Are there any questions? I don't see any.
No, I don't see any. No. A
No.
new participant, welcome.
No question.
I will stop.
Oh. Okay, so then I would suggest to continue with the next one. So to go to the transportation sector, so the one that I already announced, that was more of the first part. GIS as a basis for transformation of the transportation sector, that will be presented by Tom Hovland from Norway. So Tom, the floor is yours.
Thank you. So if hopefully you can see my presentation now.
Yes.
So thank you. Thank you for inviting me to give a presentation on GIS as a basis for the transformation of the transportation sector. It's like my whole life in one sentence. I've been working on standards since 1998, working with the TC204, which is now ITS standards, and that stands for Intelligent Transportation Systems. And I've also been involved with the TC211 for at least as long. And over the years, I've been working in both TCs and see the need for cooperation between the two TCs to move that transportation sector on. So I have a few slides that I want to show you on each of these topics. First, just to give you a background on where we are on the mobility and at the moment and ITS, and then I will talk a little bit about where we are heading and how we need the standards to come into play. So for those of you who are familiar with the transportation sector, there will be a few slides that are familiar for you, of course, but these are the four main trends that we see in the transportation sector at the moment. If you look at the upper left side, autonomy and automatization of the transport sector is a steady kind of trend that evolves by the day. But alongside that, we have the connected car. That is the instance when the car starts talking to each other and also talking to the road, which make it possible for the cars to drive closer together and also occupy lesser part of the road, and thereby actually giving free roads to other purposes in the future. And then in the lower right corner, you have the electric vehicle or the emission-free vehicles. That also is a kind of a trend that is not going to stop in the near future, at least. That means that the vehicle that actually use the roads will be emission-free at some point in the future, and that trend is very dominant in Norway. The last one is the shared mobility, that you actually match all of the transportation resources that are available to you with your own individual travel need, and then you get a kind of a seamless transportation offer to you in the end. All of these are infant trends at the moment. They have their own trajectory, they have their own actors and players, but when these merge at some point in the future, we will have a different transportation sector. And one of the needs that we do together is to standardize a lot. I would focus on automatization and connectedness in this presentation. So I just leave the other trends out for a while. And what you see here is an autonomous shuttle and an autonomous broom or street cleaner, which is pretty much the standard of where we are today, is the status of where we are today. This kind of equipment and transportation means prevails. They can do a job. They can work for us, but it's like an infant. These cannot move outside a confined area where all the geometry is known to them from before. So that's like a huge kind of missing piece still, is to move freely about as an autonomous vehicle or machine. This has to do with the technology and the maturity of the technology that we are working with at the moment. So another standards from the SAA have tried to divide this into 6 levels of automatization or autonomy. And if you move from 2 to 3, you take the move from like a driver-assisted vehicle and over to the more autonomous vehicle. Today, as I said, only the shuttles and some machines are at the 4 or 5, where you can actually use the vehicle without the driver on board. And eventually you will have a 5, maybe in 20 years, where you don't need a driver at all, and the vehicle can go all over the place automatic. Today, we have the self-driving cars firmly placed on the left side of the yellow dotted line, even though there are a lot of trials and pilots that suggest that we are further. This is probably a quite true picture when it comes to the overall assessment of autonomous vehicles in the world today. This is also supported by the Gardner hype curves, where you at the left side see in 2018, level 4 is on the downslide of the peak, on its way into the valley of despair, and the level 5 is still climbing to the top on the left side. This has moved slightly when you come into 2019, but absolutely not reassuring that we will have automated driving at any time soon. If you move into 2020, you see that we are approaching the bottom of the valley of despair, and we still have like 10 years to make it an industrial part of our life. So this is like where we are, and why we also have a time to do standardization properly before we reach a stage where this is really critical for the industrialization of this area, or that transformation of the transportation industry. So we still have time. So the way we do this, at least as a viewpoint of ITS Norway, where I'm working, is to look at the possible digitalization of the infrastructure and base that on maps, and do that for all modes of transport, not only land transport, but also air, sea, and rail. So in this instant, I would just remind you of this 0 to 5 levels, which I will repeat in my next slides here. So this is just to remind you of that. And then we kind of portray our way into the digitalization of the transport sector by grouping the responsible entity, the services, and the data and standard needed to make it work in these 3 columns. And at the bottom, at the very bottom, you see the physical road infrastructure as a black line, and above that you have the road and mapping authority making digital description of the physical infrastructure and turn that into a topology or a navigable network. On top of that, you can also give instructions to the maps on the traffic rules and how it's regulated. So this is the very basis for mobility and also for automated transport and also connected transport. So the next level are using these maps, using those to add value to them, using sensors, traffic lights, traffic signs, and also the dynamic traffic information that comes out of the traffic management centers. And on top of that, again, you can actually have the fleet operators and the manual car operations and move freely about using whatever you like. This is a picture also taken from the view of TC211, where you have the road and mapping authorities in place. But in the automotive industry, they use a different kind of GIS at the moment. That is GDF, geographic data files, and they kind of use that as an entrance to make topological maps and navigable systems for both driver support and also for automated driving in the future. So this is the big difference between TC211 and TC204, is that it's slightly different view on how to portray and how to make maps in this area. So in the levels of autonomy where we are now at 0 to 1, that will kind of equal the situation where we are today, where you use these maps for navigation purposes, more or less only. But as soon as we move into 2 and 3, things start to change. And this is where we pilot a lot of things today, and also some operations are in this area and between 2 and 3. And you see also then on the left side that the data has increased since the last slide. We have used different standards. We need the dynamic information to flow from the traffic management centers and the road administration directly to the cars using standards. At the same time, you go on using the sensors from as you used to do. So it's not just a richer picture of how you do that. Also, when it comes to the mobility part of it, you use different standards in this stage, and you can have different mobility services. So for the TC204 and the GDF, geographic data files era, we have different way of looking at this. They kind of see this as a bottom-up approach, where you use a GDF map at the bottom, then you enrich it with things that change like every month or so, and then you go to the level above where you have more like queuing and work zones and things that changes over the day, and then on the last level you have the traffic lights and kind of where you have to interact with other kind of cars and pedestrian and bikes, where you have seconds of updating of the map. So this is the challenge that is seen from TC204, that you need a map that is really accurate and still can host a lot of dynamic information. So this stage is where we are working very hard at the moment. But in the future, we will need even more when it comes to level 4 and 5. There will be no driver in the car necessarily. So a lot of things will change going up this stack here. And you see also that we have the car makers coming into play. Fleet management is coming into play on the lower level. And also OEMs, like that's car manufacturer, and map providers like TomTom here is coming in to play on a much lower level. And we need to cooperate and make sure that we are completely in line with each other. And this is where you read, you need a map that is like accurate in centimeters, where you need to know the curb height and all the particularities about the road and the sidewalks and stuff like that. So this is the way we are going, and this is where the work comes in, where we do in TC204 and TC211 together at the moment. And just to remind you that this is only for roads, and we do the same thing for rail, sea, and air, also in different working groups at the moment. So we are kind of working in all. And the red rings here denotes harbors, terminals, and airports, stations, which also kind of consist of internal networks that also make up a complexity that needs to be addressed. So we're trying to at least address these 5 entities and work with them from time to time. But at the moment, we focus on the road. So if you look at the road and road transport, we can start with this picture where we see at the lower left side, we see ISO TC204, which is Intelligent Transportation System. This is a map made from the cars driving hundreds of times. I think this is TomTom having made that map, and they make quite an accurate view of the world. So that means that the car are actually map makers as well as the other entities. As you see on the lower right place, you have an ordinary map coming out of the TC211 and also from the road administrations. If you go one up in the upper right corner, you see a kind of a point cloud. I'm not exactly how to use that terminology, but that is even more detailed maps that is made from laser, and that will kind of enrich the TC211 GIS maps for the future. And then in the end, you have on the upper left side, you have the building information model from TC59, which has also very detailed geometries on how everything was built in the first place. And together, all of these will kind of chip in and to make sure that we have a really good picture of the world as seen from the car. And the car at the moment is seeing the world through a belt. And the belt is like an electronic representation of the road where the car can move safely and also forms the boundaries of where the car cannot drive safely. So from the 4 pictures on the last slide, you have to kind of construct belts that can be enriched by all of those means from the last slide. All those 4 needs to kind of enrich the belt. This is in an ongoing discussion at the moment, how this will play out in the future. So this is also pictures taken from in the middle of a discussion. And this is where we are in TC204 and TC211 in the collaboration that we do between the 2 TCs at the moment. So the belts are like a representation of where you can drive and where it's allowed to drive, including the traffic rules and regulations. So that makes a safe environment for the car to move. So it's really important that we have this belt concept in place. Even if this technology is not going to prevail in the end, something like it will have to prevail. So that's why we are kind of working steadily to understand what the belts are and how they can drive the work further. So how do we do this? So we have chosen to work with the 3 different ISO TC like 59, TC211 and TC204. I don't work much with the TC59 from the building information model, but they certainly are important to understand how they will influence GIS and in the next phase also influence TC204 and ITS in the future. So I don't know, Knut, if I might call you a doctor yet, but anyway, I took the chance to steal one figure from your thesis. Actually, I stole 2, so I will come to the next one. This kind of lays out the connection between the BIM, GIS, and ITS, how they fit together and how they kind of belong together. I would recommend reading Knut's thesis. I really enjoyed reading them. So it gives a lot of insights to how this fits together. Also, in table 3 in one of his articles, this figure appears, and that shows the complexity of which standards belong to in this ecosystem of standards to kind of make this work, make this belt work, for instance, and which stakeholders that need to be involved. And there's quite many that needs to be involved in this work to make it kind of a whole. So this is kind of frames in what we are doing in at the moment between TC204 and TC211. We work with the TC204 to create a new version of the GDF, and use TC211 standards to kind of foster that and to actually build it. So then we need all the basic standards from TC211 to actually do that. So we are in one way helping TC204 and ITS to be more reliant on ordinary GIS models. This makes it easier to have data fly or flow between all entities in the sector. At the moment, it's not that easy to have data flying or floating between TomTom and here and the road and or mapping authority due to the lack of harmonization between the standards family. So we have set up committees to make sure that we can do that. We have on the left side here, we have the building information, which is a joint working group with TC211, joint working group 14, BIM GIS, which is led from TC59, I believe, but still very important to enrich the maps of TC211. And then again, we have joint working group 11, which is between TC204, working group 3, and ISO TC211. So this is the way we, at least I see how we work to fix this transformation of the transportation sector from the standards point of view. And in this joint working group 11, we have had done a gap analysis, making ISO TR 19169, which is a technical report in this area. It was initiated in 2 years ago, and it has been finished for a little while. It has been a really solid cooperation between the two TCs, and also kind of a model for further work. We did that technical report in quite a short time, and it is quite successful. This TR 19169, which is actually more or less written by Knut Jetlund, is giving advice on how to develop a new version of the GDF to make it kind of harmonized with the GIS standards. So, to take all the advices that came out of 19169, we have established a new preliminary work item, 5974, which is at stage 0 at the moment, where we do look into topics like the belt concept that I talked about before, linear referencing. We are looking at the time domain, also indoor navigation, which is kind of a more and more important topic to be discussed and also to be pulled into this discussion. We did all this in less than 11 meetings, so I'm quite proud of the work that we did so far. So in the end, I would just remind you that fixing land transport is only one of four domains in transport. So we need to look at the person transport using all domains. We need to look at the freight and goods transport, using all the domains of transport. And that will take a lot of work still to be harmonized. And I know that you have a maritime presentation earlier today. We are also sort of reaching out to the maritime industry and also to the entities like AHO and YALA and IMO to set up cooperation along the same line as I showed you on the previous slide. But also we have drones coming into the picture. And we also have digital infrastructures that covers hubs like stations and terminals and stuff like that. And we need to embark on gap analysis to see where we are and where we are going and what we need to do in all these domains. So I believe this wraps up my talk. Thank you for listening.
Thank you very much, Trond, for this another quite complex, let's say, presentation of quite complex and successful cooperation here. I think there are already some comments and some people already joining with the camera. Maybe they would like to have some questions. I think there is Martin Puchar. You would like comment something? No? Okay, so they're going back to the chat box. We have Thomas with some comments. Thomas, please.
Yes, thank you very much for the great presentation. just two comments. One is on the Open Drive standard, which is strongly evolving over the last years, and also the uptake of that standard is quite big. At least with the big German car manufacturers, but also I think others are really now using it. There is a lot of similarities in that standard compared to what you've showed also with ITS, and I think that's really also useful to see if this can be synchronized and further synchronized. At least I think we have been in touch with that consortium, and I think we were able to convince them that in the new version of Open Drive, they should probably make use of the ISO 19100 standard series. So basing it on maybe the general feature model and also about the spatial model, etc. So there is currently, this is really strongly being considered in this group. And so there could be chances on synchronizing that. And one more comment, please, from my side is CityGML, as the standard has recently got an update, and CityGML 3.0 will be released in the next really couple of days, by the OGC. And we have also included strongly extended traffic or street space modeling, you could say. And I think this could also be very beneficial because it has a different view on the cities than BIM, because BIM, you need to know all the components, etc. And CityGML is closer to GIS and its representation. So maybe if you have not found the time or yet had any possibility, I think it's at least worth giving a look.
I thank you for those comments, and I do agree. To some extent, we have been reaching out to those entities, but we still need to do that more. Mm-hmm. OGC is on board in the Joint Working Group 11 at the moment, but mm-hmm. we simply haven't had the time to address all these issues. And we know about Open Drive and also about the CityGML that this is important features. And we are also trying to reach out to the car manufacturers at the moment because we suspect that they have a slightly different view on this. And we need to make sure that we are on the right track, also as seen from the European car manufacturers.
Of course.
You know that this belt concept probably comes out of the Japanese Toyota and Honda situation, but will that be viable for European and American cars? So we are in that phase where we actually double checking that we are on a track that is worthwhile being on.
Yeah. I personally just can tell because we are in a couple of projects, and one big project together with Audi, where we are looking at autonomous driving and driving support systems and the kind of 3D models that are being required. And together with the city of Munich, we are building up a very detailed street space model for entire Munich, because they want to do traffic simulation down to the lane level in order to estimate emissions in the city and also to see what effects it will have if you replace some car driving lanes by bicycle lanes, for example, and also for e-mobility, where to put charging stations, etc. So there is currently really there are a lot of things going on in this area, and also data are currently being acquired for example, for entire Munich.
I just took note of what you're saying. I think it's worthwhile to follow up on. Thank you.
Yes. Okay. Thank you.
Thank you, Thomas, for the question. Thank you, Tom, for answers. I think before we are coming back to you, Thomas, there is another question to Trond from Martin Pucher. Please, Martin, would you like to ask a question?
Well, yes, I can do it, but I'm listening this day, this really nice, interesting topics, and I'm asking. I'm not sure that if this is the right question for this presenter, Mr. Ton, but maybe also for others. What is the relations between, let's say, different initiatives that are going on, especially related, as I know, with different topics in GAIX initiative on European level, where different, let's say, topics are covered as well and try to be standardized. And maybe within this or parallel to this also Fiverr initiative, which is very strong related with smart city domain and standardization on that level. And I didn't find any good relationship between ISO standardization technical groups here and all those initiatives I'm talking about. So maybe some other colleagues know much more about this, or is this something to be connected still?
Indeed, maybe there's some of this question can be answered partially by Trond, maybe also by Sankey, Chris. So please just respond, whoever wants to respond first. Maybe Trond, you.
Yeah, I can just say that it's a good question, and we are looking into to the smart city family of standards to make sure that we are at least aware of what's going on there. When it comes to Gaia X, I've read through what's there, and I see that it's kind of it backs up some of the things that we are doing, but I haven't been able to actually do something about it yet. But I am aware of those two, at least Gaia X, and I think that smart city initiatives and standards will be needed to make this ecosystem and transformation of the mobility industry a whole thing in the end. It plays into so many aspects of the daily life in the future. So I took note of what you were saying, Martin, and I will show you for follow up on that. Thank you.
Maybe I can add something on Fireware, because actually we have also had a close look at Fireware in our smart city projects, and it seems that Fireware is reinventing the wheel of geographic representation in their standards, and without taking notice of OGC or ISO TC 211, which I think is not a good idea, because they come up with very simple data models, and then they say now people should create domain-specific data models without ever knowing that there is already huge families of data standards out there. So I think it's definitely also worthwhile maybe approaching them. But Fireware is, of course, not Gaia X, so there are also differences in that. I hope that Gaia X is going to have more mainstream IT support than probably the rather European proprietary parts in Fireware. But that's okay. My observation.
Thank you, Thomas, for your comments. I don't know if anybody else would like to comment the question of Martin. If this is not the case, I will thank you, Trond, for presentation once again, and we'll give floor back to Thomas. So Thomas, you're back on stage. So now it's your turn to share with us how geospatial modeling links to the general indicator modeling framework for decision support. So yes. Please, Thomas.
Okay, thank you very much. So I would like to take up the idea of doing standards together, and especially there was also the topic already today of how to crack the silos, the information silos, how to connect information. And I think this kind of a concept that we have developed over the recent years at our chair may be something that could be also interesting for ISO. Maybe also, I don't know, it could be considered in the future as a standardization activity. At the moment, I don't have a dedicated plan because I also don't have a dedicated financing for going in such a way. But let's see. It's joint work by Mostafa El-Foli and Tatjana Kutzner. Both are also online. And it's mostly also really the PhD work of Mostafa. And so, however, I took the opportunity today to give this presentation. And so, what is it about? I mean, in smart cities or in general, if you are using GIS data for specific decision support, may it be in the energy domain. So you want to know which buildings are suitable for retrofitting, or if you think about traffic planning, or transportation planning, then where to put a road, which road should be closed. So in order to change then the flow of traffic inside the city, it all comes in the end basically to measuring landscape and city performance. And I'm not just talking about measuring indicators on the level of the entire city. No, the energy demand of a single building is of course already an indicator. Of course, you can aggregate those indicators then to a level on the district levels. You can say, okay, for the entire city quarter, we have that amount of heat energy demand. And at the same time, you can also think about what is the solar energy that can be generated, and maybe also that is currently being generated for a certain district. And again, these are indicators. However, they are always related to geospatial objects in this case, the building. If you think about what's the average driving speed inside a piece of road or inside a section, then within a section, then again, this is an indicator which can be associated with the piece of road. So again, we are interested in having basically different kinds of indicators which are from completely different domains. And so you see, we have ecological indicators, we have financial indicators, social indicators, etc. And all of them are related somehow to the landscape or to the city and its parts. And typically, when you have very important indicators, people are talking about key performance indicators. And you already mentioned this today. I think ISO TC 268 has also these smart city indicators, which is, I think, 37120 or something, that ISO standard, which is also defining indicators to measure the performance, the smart city performance of cities. The question is now how to compute those things. And on the one side, you can see we have these kind of indicators on the left side. So you see we have energy indicators, mobility, etc. And then on the other side, we have existing data. And data which comes from completely different organizations and which also come in different data models. And so, for example, what you see here is everybody of you is probably familiar with Inspire. That's the European data modeling and the European spatial data infrastructure, which includes a set of data models. Then also we have, this is just an example from Germany, ALKIS and ATKIS. This is the German cadastral standard and the German topographic data modeling standard. But of course, other countries, UK has Ordnance Survey, MasterMap, and others have similar data models. Often they are nowadays modeled based on ISO TC 211 standards. And of course, there's also CityGML data, which is representing 3D, semantic 3D city models. And finally, BIM data also. So we have very detailed representations of the built objects. And now the question is, how are these related? And observations that you can do is geo-based data are typically available for entire countries, or at least for entire cities, and they can be used to compute these indicator values. Often, however, you need additional domain-specific data. So some information, for example, if you want to determine the energy demand of a building, you need at least have some information about the construction type of the building, and often the age of the building or the age class is being a good indicator to be used to derive, for example, insulation values for materials from that. So these kind of information may not be included in all city models worldwide. So you may need some additional information. However, all these geospatial information that I've mentioned before are based on standardized semantic data models, or sometimes you can also call them ontologies. And so far, the indicators, however, they are typically not formally modeled using a standardized framework. And also no systematic model exists yet to link indicators and these kind of geodata or geo-based data. And and that is basically addressed by this framework, which I would shortly like to present. The entire framework is based on the idea of model-driven engineering, which is, I think, of course, also the underlying principle that is being used here in the ISO TC 211. And basically, MDE puts the model in the form of formal specifications in the center of software analysis and design. And application relevant structures are represented by formal data models, for example, using UML. And MDA, which is also being used in ISO TC 211, is considered being a part of MDE. And the idea is, of course, to, as far as you can go, derive automatically other models or also program code from this kind of model-based representations. However, there's an important thing in MDE that is not so much addressed in others, for example, in model-driven architecture, is the linking of different models. When people today talk about linking of different models, they often talk about ontologies. And they say you need to use an ontology. No, you can also use MDE from the domain of data modeling. And so You can also use UML, and you can also use all the representations that are very common to everybody here in TC 211. And this is then called model weaving. And so different models are then linked by what is called a weaving model, which takes care of data transformation across the models. You know, to sketch the idea is to say, okay, let's assume we have the different levels of modeling. For example, in geospatial information modeling, like is supported by ISO 1909 and also the national data models that are being used, you can see they are residing on different levels of this MDA hierarchy. And you can say, okay, in the lowest level, let's assume we are looking at CityGML as a specific application schema. Then on the lowest level, M0, on the instance level, we have the objects of a specific city model. For example, the buildings of Berlin. So these are the instances, and they all are modeled according to that data model here. And that's basically CityGML. And CityGML tells, defines the structures of all possible 3D city models. So CityGML is being used not only in Berlin, but also in Singapore, in Tokyo, in Hong Kong, and in Rotterdam, Zurich, etc. So in many, many cities around the world. And however, that data model, again, follows a certain principle, and that is being defined here with a general feature model. So the interesting part is that, for example, the Inspire data models, they would be, you could say, brothers or sisters to CityGML, and the national mapping agency data models like OS MasterMap is also a brother of CityGML because all of them are modeled according to the general feature model. Okay, and also LADM would also maybe belong to that. Now, let's extend this to indicators. Why, when we have geospatial data models, why don't we have a similar framework for indicators? That's the question. And here's an idea to say, okay, I may have an indicator, a key performance indicator A for building Y. That could be, for example, the heating energy demand of that building. And that is an indicator that is very specific and tightly coupled to this object. And then, however, that indicator also needs to be modeled somehow. So we need a framework or a data model to represent it. And our suggestion is to have here, similar to application schemas for geodata, also application schemas for indicators. So you can then say, okay, let's model the indicator here separately from the geospatial model. And then we can also have other application schemas. So we may have energy-related application schemas, we may have climate-related application schemas, we may have traffic-related, etc., etc. And then also these objects on the bottom level are linked to these indicators. And then, of course, we need, similar to ISO 1909, we would also then need a concept that would be called general indicator model. And so, and these schemas would then be an instance of this one. As like CityGML is an instance of the general feature model, then an energy-related application schema could be an instance of this one. And there is, of course, then the linking. And here you can already see what I mean with breaking up the silos, because this is now really linking data from different domains and different application contexts to existing geospatial data models, not just CityGML. This is just an example here. And so there are then requirements in for this indicator model. First of all, you need to be able to support different kinds of indicators. We have numerical, textual, categorical indicators, etc. Then we can also think about, we have complex indicators that can be composed and computed from attribute values from associated city and landscape model objects. We need to be able to express constants and mathematical expressions. And of course, we also have indicator value aggregation, like summation, average, maximum of other indicators. So for example, the heating energy demand for a district consists of the heating energy demand for all individual objects in that district. So, and that can be also expressed using UML. And what we can also do is we augment indicator values, or what we can do is we can augment indicator values with meta information, like accuracy, lineage, source, etc. So, and if you would be able to model for each individual indicator value also the accuracy, you can then also include sensitivity analysis along the processing chain of the computation of the indicator. So it can really lead back to the original data sources and the original data items and say, okay, what's the provenience of that specific indicator value? And so that's also a chance here. Let's give you an example. And of course, I have to use a little bit of UML, but it will not be coming too difficult, I promise. So what you see on the one side is now, let's assume you're an energy planner and you want to talk about heating energy demands in cities, because that's an important topic also for smart cities, for example. Then, of course, you have an idea about your indicators you're interested in. You probably don't have an idea about Inspire data models, about CityGML, about OS master map, or about the German national models, etc. So first of all, you're interested in your own representation. And then let's assume we have something that is called heat demand or heat energy demand. And then you can already see, we can say, okay, that's a subclass of a numeric indicator. And here, every indicator has a value, and so this will be inherited, so the heat demand would have this attribute value. And then, however, heat demand for itself does not make sense, because the heat demand is always the question, heat demand of what? The heat demand of my car, the heat demand of my building, or whatever. So these kind of indicators typically only make sense when they refer to some reference. And often the reference is an object, a geospatial object. And that's basically expressed here. So we have further sections now in our schema and say, okay, we now have to create object-related domain indicators and say, okay, we have something like the district heat energy demand. That's interesting for the energy planner or for the urban planner. And then, however, we also have the building heat energy demand. And both of them are subclasses of a heat demand. However, they are a little bit more specific because they also need to relate to a reference object. And here you can already see, here we have now an interface. And that's basically the interface to our other existing geospatial standards. However, that kind of systematic approach, first of all, it would allow that the energy planner can create such a model without thinking about whether in CityGML buildings are modeled in that way or in this way, or whether to use IFC and for BIM and having the specific modelings there. So it's really the idea of separating these concerns. So that model is completely defined purely from the logic and perspective of the energy planner. And then, however, so you can see many of the reference objects in the context of urban and landscape indicators, they are spatial objects. And then we can see, okay, let's have a look at an existing geospatial information model or geospatial application schema. CityGML is just an example here. It could also be OS master map, or it could also be some Inspire data model. And now the point is actually, you have here the existing data model, and that's the domain of the geodata provider, and also of ISO TC 211, for example. And then, however, you need to see how difficult it will be to connect the reference objects that are required here with existing feature classes and feature objects of that data model. And in this case, for example, you have what is called a building connector, which simply connects the class building from CityGML with a building that is required here as the reference object. And then in CityGML, we don't have a class called district. However, what we have is the class called city object group. And that is also used to model, for example, urban districts. And it can also be modeled to model the entire city or group everything inside the city. So what we made is now the connection here to this connector. And now you have a complete chain. And the idea is then adding OCL rules here at two places. One place here at the connector and one place here at the object-related domain indicators. And in these OCL rules, we embed the computation rules and say, okay, that value here, the volume, is taken from that model by applying the volume calculation on the 3D solid. And here, however, the energy demand in the end is being computed by taking into account the building volume, maybe also the building H class, etc., etc. And then, however, this is being expressed as OCL on this side here. And this is further explained a bit. So using what object constraint language is being used. So you see here, the building heat energy demand is, for example, let's assume we say the building heat energy demand can be computed by taking the volume multiplied by 0.97. This is a fake formula. Of course, we did already this with real also other ISO standards for energy demand computation. And the models are really huge. But of course, it was possible, and we can show it. And we did a master thesis showing how these other standards for computing and building energy demands can be mapped onto this schema. And then, for example, for the district heat energy demand, you can simply say, okay, summing up, it's basically the value is simply summing up the heat demands of the instances that exist here. So, and second OCL rule is at the weaving class, because we have to provide building objects here. And so we need to provide a rule here, which simply says, okay, there need to be a building object here, and there is one object here. And however, in order to set this volume here, we can take the volume that is here as associated from the building data in CityGML, or we can call a function to compute the volume, maybe from the associated solid. That's also a possibility. So let's quickly summarize that. Each indicator application model is defined purely from the viewpoint and requirements of the domain specialist, because what we don't want is that the domain specialist have to learn in the first place how a specific data model, CityGML, IFC, or something looks like, because then sometimes people make suboptimal decisions how to model their indicators. And so it's just modeled from their perspective without taking into account any geospatial data model. And then the data model is separated into 5 consecutive sections. You have the abstract indicator classes, the domain-specific indicators, object-related domain-specific indicators, and the reference objects. And the 5th section, it addresses the linking of the indicator model with a geospatial application schema like CityGML or Inspire. And the weaving classes relate reference objects with feature types from the geospatial application schema. And this is, again, the diagram that you've seen before, and here are those 5 sections. And you can really create this in a systematic way. And I can also show you an example in a minute. This is now I won't explain that in too much detail, but this is basically the meta model for the general indicator model. And this is, you can say, the analog data model as is given for ISO 1909. ISO 1909 is the general feature model, and which also has a UML diagram. And this is exactly the similar thing for the meta model. And also here, you can see basically these sections, which I have shown before, where you can find them. Here are the concepts which are defined here. So that's the meta model. What can you do with this? I mean, one thing is you can say, okay, I can really say for the domain stakeholder, please try to represent your indicators in a standardized way. Standardized means use UML, use OCL to express computation rules, and do that kind of 5 sections, or at least in the beginning 4 sections of the modeling. And then, however, you can check what data set and what data model out there in the free world or in the wild world is probably easiest and most powerful or rich to connect here, which can probably provide all the data that is being required here, because the rest is all derived from here. So that means you really have to check for the coherence of these 2 data models. But this framework also allows to assess this. We can find out how many one-to-one object mappings can we find. For how many cases we have a more difficult situation like 1-to-n, or in the most difficult cases, n-to-m. So n objects here representing m objects here, which is a bit of a problem then. But then, of course, you can also do the weaving to inspire data models. And you can also do the weaving with BIM and IFC, for example. And then you can really assess for which one, maybe also, first of all, is data already there? Is there already a city model in CityGML? Maybe there is no data in Inspire, so that could be then this way. Or if you really say, okay, we need data to compute this, but which is probably the best data model in which my data should be coming, my spatial data should be coming and be related here. So where's the pain? Where's the least weaving pain, I would say? And so we can analyze and compare how good and easy an indicator model fits to a specific geospatial application model. And this, I don't expect that you can read this because there is a link here at the bottom to a paper that was written by Mostafa and Foley and Anna Lawecki from TU Delft, who jointly worked on using this framework to see how parts of the US standard HASUS, which is basically a framework for hazard assessment and hazard analysis, being mapped. And what is shown here is the modeling of flood damage assessment for buildings. So if buildings are being flooded, there are also computation rules defined in this HASUS framework, also how the American government computes costs and how insurance companies can compute compensation costs for building owners. And this was able to be completely mapped on this framework. And the different colors show the different sections. And this is on the left side CDGML. And it was also shown how this could be created in a complete chain, and then also how programs could be derived, which then basically on the basis of CDGML data plus some extended data can really lead to full computation of all the indicators. So that's basically the step here. And then this is a slide I added just a couple of minutes ago. You see this hand drawing, and of course you can think about cracking data silos by connecting domain data, for example, using CDGML. You have the CDGML data model, and then you have a weaving model, maybe to some real estate management and value assessment indicator model. You have urban planning indicator models. You have energy demand estimation models, traffic simulation, etc. And what I can tell you is all of the examples I'm giving here have been implemented already. So this is not just future work or something. This is already has been achieved in the past. And also CDGML has a mechanism that is called application domain extension, ADE, which then basically would allow to even map this kind of extension as an extension to the CDGML core model. But as I said, the entire general indicator model framework is not specifically to CDGML. It also can be applied to all the other data models. However, just here to show this basically taking up this, and here is basically to show, okay, the city model can be a very good integration point for all these different kinds of use cases and applications. And how is it done? Just here an example. You have a building model, for example, and then you have information about energy, about noise emission, about economy, etc. And all of this is related to the very same real world object. And this is not just a graphical or geometrical representation. It is a semantic object and represented as a building. And you don't need BIM for that purpose. So BIM is overkill in this case, especially when you go for an entire city represented like that. Okay, so, and again, yeah, if you have a city model like that, you can map the city as a specific time point, and then of course you can compute all the different kinds of indicators, and by using simulations and calculation tools. And then of course you can also virtually carry out planned actions, change the city model, and rerun all the simulations to see how this will affect it. Okay, coming back, final slide. So the general indicator model is a new framework. In fact, it's from the time perspective, it's not so new because we have been working on that now for a couple of years, but still we are currently finishing a publication on that, which needs to be published. And we have indicators for different domains in a standardized and interoperable way using UML and OCL. So that means we are using the same language as ISO TC 211 also uses. No need for OWL or for other external further standards in this case. You can link these models to the geo-based data using model weaving, and it facilitates the systematic analysis of indicators, the relationships to digital landscape city models, but also to BIM. And we can explain key performance indicators represented by 3D models. And I think that should be enough.
Thank you. Thank you very much, Thomas, for your presentation. I liked it very much because you modeled a very quick solution for cracking the silos actually during the presentation. I've seen that also Tatiana and Mostafa are here, so your co-authors, maybe they would like to complement something, to add something. I don't know, Tatiana, Mostafa.
I I mean, I don't know, can you hear me?
Yes, so I think
Yes.
Thomas gave already a great presentation and included the most important aspects already.
Maybe they can, if there are questions, they can answer on the question.
Yes, so you will see that there are some questions, some comments already, one by Peter. I think, Peter, would you like to extend your question?
Yes, so I was asking, there's an ISO IEC standard called, exactly what it's called, but it is effectively a top level indicator ontology. So a data model for which seems quite similar to your general information model, but modeled in OWL rather than UML. It's similar, not so much in content perhaps, but in intent. And I just wondered whether you or your PhD student has looked at all. So it's ISO IEC 21972. It's emerged out of work done at the University of Toronto. The editor was a professor there.
Actually, maybe I don't know. Tatiana or Mustafa, do you want to answer?
So I saw that it's a quite new standard. It's from 2020. And the work we did, so we started a few years ago. And so back then, the standard was not yet available. So I think we should look at it. And I think it was in the comment that it might be similar to the domain indicator model. So it could be a good example then for the domain indicator model.
Yeah, exactly. I mean, I think it was the same. It was in 2020, and we started working actually in 2014 or 2015 on the topic already. But it would be something good to look at as well, that we refer to and check what they have developed as well.
I mean, so the standard was published then, so obviously the public draft was 2019, but the actual research work in Toronto was published in about 2014, 2015. And anyway, it's just raised that as a thing that might be worth looking at.
Mm-hmm.
Thank you, Peter. So I think there was another comment / question by Robert from New Zealand.
Yes, I was just wondering whether there were parallels between the indicator work and the O&M standard and approach and the other data models that have arisen out of that in OGC and TC211.
I'm not sure if I understood correctly the question. Could you please repeat?
In OGC and TC211, there is an observation and measurement standard,
yes,
19156. And I wondered what the parallels might be, because it's a basis that is then used for, in the environmental space, for GeoSci-ML, SoilML, and all of these sorts of things. So I was wondering whether there was a parallel between that framework and the indicator framework, or whether there was a critical distinction between them.
Well, actually, I think we haven't really matched this against each other. But if I think maybe the O&M model could replace our just the representation of our basic indicator class, but all the other sections that we have looked at, making the separation between the general indicator, then the object-related indicator, and the reference objects, and then the weaving. That's basically something that would have to be added anyway, and this is not addressed. I mean, O&M has a possibility to say, okay, that observation was made by looking at that feature. So you have that relationship, but that's very, very coarse, a very, very coarse relationship, and does not really go down to the level of individual attributes where you link maybe an observation to a very specific attribute of a specific object.
Okay, thank you. Let me check if there is another question. Yes, there is another one, Sagar Sonone. Sagar, would you like to ask the question, or I can read it?
Yes, if you can hear me.
Yes, sure.
This is Sagar. I'm currently building a smart city model for Middle East, Qatar. So I was just wondering if there are any standards or site suitability techniques which we can derive from the collected data in your models.
In principle, it could be applied. The question is, how do you measure site suitability? If you have rules, or if you are able to express mathematical formulas to give you some indicators for site suitability, then this model could be applied. So, but it really means you need to think about, okay, how do you evaluate site suitability, or at least what are indicators that are important for a planner to decide about site suitability. So maybe not in the end one indicator saying yes or no, but maybe having a set of 20 indicators that the urban planner will always have to have a look at and check. These indicators could be, of course, expressed using this kind of framework.
Okay. Thank you. I see there are no further questions. So thank you once again, Thomas, Tatiana, and Mustafa for presentation and for answering to Peter, Robert, and Sagar.
May I just ask one question? Would this be in principle? I mean, you don't have to answer this now, but would this kind of modeling framework, would be this something interesting for TC 211, or is that something that is not out of the scope or out of interest for you? I know it's all the question who will be doing it and funding, etc. So there are a lot of things around it, but.
Peter, maybe?
This is Senki Hong here.
Senki.
If I may, of course, it is very interesting idea, and you know, as you see in my presentation, we always concerned about how we link all these different data models and application schemas and things like that. And we've been looking at all these different ideas, and it's a great way of linking data models. So it is, of course, our very interesting topic to discuss, and we'll follow up on that.
Okay, thank you.
Okay, thank you once again to all. So let's move to the last but not least presentation. So I'm inviting now to share the presentation Insong DU. With the model approach helps bridging standard-based multidisciplinary imagery and gridded data. So maybe in the meantime, while Insong is starting to share the presentation. Are you still here, Insong?
Yes, it's speaking.
Yes, perfect. So while you are starting to share the presentation, so maybe you're aware that ISO TC 211 last year, before the 50th plenary week, started a challenge by the initiative of the chair, user story challenge, and with which ISO TC 211 started to collect different user stories, good practices, implementation of location standards around the world. And this presentation today is one of those. So please, Insong, the floor is yours.
Okay, thank you. Okay, this is my talk. Modular approach helps bridging standard-based multidisciplinary imagery and gridded data together. And this is based on ISO 19105, geographic information conformance testing and testing. Okay, big data is quite a hot topic in earth science market. We have manifold big data in standardization stream. For example, we have coverage, features, and etc. ISO, OGC, W3C, IETF, and several famous international standardization organizations have contributed greatly to standardization based on the standardized sheets. The standardization work has the potential to solve a large range of questions today in the context of big data. Actually, not on big data assets, but also on analytics on variety of data. Then the problem is how we can test this together for our standardized solutions. In ISO or UTC, coverage data and service related standards contribute greatly to imagery interoperability by demonstrating of convenience of the standard-based techniques for Earth science system. These standards include service model, protocol binding, encoding format, data model, etc. More is coming underway. Research community can continue to use different standardized technologies and best in mixed mode to address the analytic challenges. This is our standardization story. We are using the IGSO and the OGC coverage-related standardized solutions to demonstrate our national forest city, Fuzhou. A specification-oriented modular approach is adopted to achieve reliable interoperability by orchestration a variety of web coverage-related standards. For example, ISO 19163-2, ISO 19123-2, and the OGC WCS 2.0 series. The solution makes sure that the provided imagery and graded data is concrete in terms of testable data structure, definition, and the integrated constraints, and therefore enable rigorous conformance testing down to single pixel level through the mechanism established in ISO 19105. Okay, this is the general testing framework. The solution is carried out based on some standardized implementations, for example, Rasterman, TND2, OpenLayer. The test scripts are customized according to the abstract test suite provided in the standard documents. The testing will check the solution is conformant to the standards. Here we use OGC Team Engine to customize the test suite, test scripts. Specifically, these are the standards we used for the solution. This includes ISO 19105 for testing, ISO 19123-2 for coverage, and actually this ISO 19123-2 it is also OGC CIS 1.0. And we also use ISO 19163-2 for imagery and graded data, and the OGC WCS 2.0 for service interfaces. Actually, these standards all follow modular approach. Therefore, we can implementations follows these standards can be orchestrated quite easily. Then I will go these standards one by one. But regarding the ISO 19105 implementation, a conformance testing framework is provided. See the figure below. In this framework, a standard or specification contains requirement classes, which are used to derive an abstract test suite. An implementation under test is derived according to the standard or specification. And then an executable test suite is implemented according to the abstract test suite. The executable test suite will test the implementation under test to determine if it meets the well-defined set of requirement classes as stated in the normative clauses. Finally, a test report documents the results of conformance testing by considering the dependency relationship among conformance classes. This is ISO 19123-2. These documents specify a concrete implementable conformance testable coverage structure based on the abstract ISO 19123. This document also defines the structure that is suitable for encoding in GML and many encoding formats. Domain model can be added to the coverage structure for use if needed. In this way, in this story, we use ISO 19163-2. Okay, then let's have a look at the ISO 19163-2. This document specifies an implementation schema based on the content models for geographic imagery and graded thematic data defined in ISO 19163-1. In this story, we binding ISO 19123-2 and ISO 19163-2 together. In this way, our imagery can be served by OGC WCS 2.0. Then let's have a look at an OGC WCS 2.0. OGC WCS 2.0 offers multi-dimensional coverage data for access over the internet in a standardized way. It contains a core and several extensions. The core defines the basic coverage access functionality, downloading a whole coverage or some special temporal part of it. The service extensions add further functionality, phases, and the protocol bindings. This is the technical standard node for our solutions. We have logic N and O in our graph. N means each component passes the test according to the corresponding standard. O means at least one component passed the test. Then I will have a brief introduction on how to use, how to use ISO 19105. Actually, this depends whether you are an implementation developer or test developer, solution provider, or standard author. For an implementation developer, the developer needs to find the right modules in the conformance clauses and follow the corresponding requirements, pass it correctly, and implement the implementation. For a test developer, the developer find the right abstract test suite and derive the test accordingly. For a solution provider, the provider need to find the implementation which implements the right modules and need to orchestrate this standardized based implementation in a proper way. Then find the corresponding testing and carry it out and test accordingly. For a standard author and for who wants to follow the modular approach, it would be better that the document is provided in a structured way that follows the modular approach, which means it need to contain conformance classes, requirements, abstract test suite, and etc. Okay. Oh. Summary. In this presentation, in this standardization story, we have online analytic ready image data, which orchestrates a variety of web coverage related standards from ISO, W3C, OGC, IETF, and etc. And this story is based on existing standard-based approach, based on OGC WCS 2.0. Then we can use this to assess our data. And we can provide a concrete implementable conformance testable coverage structure as defined in ISO 19163 that conforms to ISO 19123-2. And follow the modular approach, we can do the overall assess. We can have a global validity of the cross-reference statement because there are dependency relations there. We can spot inconsistency and incompleteness among requirements, implementations, and test, and do the revision accordingly, either on standards or implementations or tests. Because I'm the project leader of the ISO 19105 and also the main contributor of the ISO 19163-2 and 19123-2. And thank you very much for the contributions from the ISO OGC and especially for the project teams of the ISO 19105, ISO 163-2, and ISO 19123-2. And thank you very much. This is my talk.
Thank you very much. for your presentation and sharing with us the story, the user story, or good practice of usage of the ISO 19105 for the conformance and testing in China. So any questions and comments? I am aware that we are running quite late. So we have a next meeting in 15 minutes. I don't see any questions at the moment. So I would like to thank you for your presentation, Sandy. So I think we are at the last point, so the closure. So I think even though that we were a bit late today, so it was worth to extend a bit. Thank you for your patience. Thank you for your participation. And first of all, thank to all the presenters and the panelists today, which were giving us really nice insights on the, let's say, what has been done in the ISO TC2 committee, but not also ISO TC2 11 committee, not only internally, but also externally with cooperation with different liaisons, either internal, external, and other organizations. So thank you for being with us, and see you at the next edition of Standards in Action seminar in late autumn, early winter, in whatever format it may be. So have a good day, and to all the delegates of the ISO TC2 11, I wish a successful continuation of the plenary week.